Welcome to the Ultimate TypeScript course. In this course, I'm going to teach you everything you need to know about TypeScript from the basics to more advanced concepts. So by the end of this course, you'll be able to use TypeScript to build large-scale applications. If you're looking for a comprehensive, easy to follow, well-organized, and practical course that takes you from zero to hero, this is the right TypeScript course for you. Everything you need to know about TypeScript is in one place, so you don't need to jump back and forth between random tutorials. I'm Mosh Hamedani, and I've taught millions of people how to advance their software engineering skills through my YouTube channel and online school, CodeWithMosh.com. If you're new here, be sure to subscribe as we upload new videos all the time. Now, let's jump in and get started. To take this course, you need to know TypeScript. No, that was a joke. You don't need any familiarity with TypeScript, as I'm going to cover everything from scratch. But because TypeScript is built on top of JavaScript, you need basic familiarity with JavaScript concepts such as variables and constants, arrays, objects, functions, arrow functions, destructuring, and so on. If you need to refresh the basics, I have a bunch of tutorials and comprehensive courses you can take. I've put the links down below in case you are interested. So, assuming that you're the right student for this course, now let's talk about how you should take this course. First and foremost, I want you to watch this entire course all the way from the beginning to the end, because every lesson teaches you something new. If you have taken any of my other courses before, you know that I don't waste your time with repetitive or useless stuff. So make sure to watch every lesson. Now, while watching each lesson, I want you to take notes. You can just write down some keywords on a piece of paper if you don't want to write a lot of notes. I strongly believe that the act of writing things down will help you remember new things that you learn. Now, when you get to the end of each section, make sure to do all the exercises. I've carefully designed these exercises to help you better understand and remember the materials. Remember, the more you practice, the better you'll be at TypeScript or coding in general. Welcome to the first section of the Ultimate TypeScript course. We're going to start this section with a quick introduction about TypeScript. We're going to talk about what it is, why we use it, and when. Then we're going to set up our development environment and create our first TypeScript program. Next, we'll talk about configuring the TypeScript compiler, and we'll finish this section by talking about debugging TypeScript applications. So let's jump in and get started. Let's start by talking about the top 3 questions people ask about TypeScript. What is TypeScript? Why do we need it? And how is it different from plain or vanilla JavaScript? Well, TypeScript is a programming language created at Microsoft to address some of the shortcomings of JavaScript. You can think of it like the brother or sister of JavaScript. JavaScript is like a kid without any discipline who does whatever he or she wants. TypeScript, on the other hand, is like a kid with some discipline. Now, technically speaking, TypeScript is a programming language built on top of JavaScript, so every JavaScript file is a valid TypeScript file. But TypeScript adds some really cool features to JavaScript that help us build more robust and maintainable applications in less time. The most important feature TypeScript offers is static typing. What does that mean? Well, we have 2 types of programming languages, statically typed and dynamically typed languages. In statically typed languages like C++, C#, and Java, we know the type of variables at compile time or while coding. For example, we can declare a variable of type integer, and this variable can only hold integer values, nothing else. So we cannot set it to a string or another type of object. In dynamically typed languages like JavaScript, Python, and Ruby, the type of variables is dynamic. So it's determined at runtime, and it can also change. So we can declare a variable, set it to a number, and then later on, change it to a string. So this variable does not have a fixed or a static type. The type is determined and may change at runtime. Now, this is great and gives us a lot of flexibility, but it can also lead to problems. What if we pass this variable to a function that expects a number? Then our application might misbehave or crash. Now, the problem is that we will not know about these issues until we run our application or our unit tests. Well, assuming that we have them in place. So we have to test every function with various edge cases to catch these bugs. And this is the problem that TypeScript tries to solve. TypeScript is essentially JavaScript with type checking. With TypeScript, we explicitly set the type of our variables upon declaration, just like how we code in statically typed languages. Then we pass our code to the TypeScript compiler, and the compiler will tell us if we are doing something wrong. So we can catch a lot of our mistakes at compile time. So if we declare a variable as a number, we cannot set it to a string. The TypeScript compiler is going to stop us right there, and this happens at compile time. So we don't have to run our application or our unit tests and test every piece of code to catch these errors. We can catch a lot of them simply by compiling our application, okay? But TypeScript is more than just type checking. Most code editors these days have great support for TypeScript, so they can detect the type of our variables and offer productivity boosting features like code completion and refactoring. Also, TypeScript includes additional features that help us write cleaner and more concise code. Now, over time, these features get added to JavaScript, but because we have various browsers and runtime environments for executing JavaScript code, it takes some time until these features are implemented in various browsers. So by coding in TypeScript, we can use the features of future JavaScript. So in a nutshell, TypeScript is built on top of JavaScript, and we can use it wherever we use JavaScript, on the front end or the back end. So anything we can do with JavaScript, we can also do with TypeScript. Now, all these great benefits aside, let's talk about the drawbacks of TypeScript. First, with TypeScript, there is always a compilation step involved because at this time, browsers don't understand TypeScript code. So we have to give our code to the TypeScript compiler to compile and translate into JavaScript. This process is called transpilation. Second, with TypeScript, we have to be a bit more disciplined when writing code. So if you're a lazy programmer like our famous old John Smith and want to get things done quickly, you may feel TypeScript is getting in the way. And that's true. But if you're working on a large project with multiple developers, you would end up wasting more time coding in vanilla JavaScript and catching those nasty bugs. So then you really want to use TypeScript. For simple applications, you can totally get back to old vanilla JavaScript if that's what you prefer. All right, that's all about TypeScript. Next, we're going to set up our development environment. All right, the first thing we need is Node because we're going to use Node Package Manager or NPM to install the TypeScript compiler. I believe as a student of this course, you should have Node on your machine, but if not, head over to nodejs.org and download the latest version over here. Once you do that, then open a terminal window and run npm, that is short for Node Package Manager, which we're going to use for installing third-party packages, in this case, TypeScript. Then we type I, that is short for install, -G for installing this globally so we can access the TypeScript compiler in every folder. And then we type the name of the package, TypeScript. Now, if you're on Mac or Linux and you get a permission error while running this command, you have to prefix it with sudo or sudo. Well, more accurately, this is sudo because it's short for super user do. But that aside, let's go ahead and install the TypeScript compiler. Okay, great. Now to verify our installation, we type tsc, that is short for TypeScript compiler, -v to get the version. So here I'm running TypeScript version 4.6.3. You might install a newer version, but don't worry because everything I'm going to teach you here will apply to newer TypeScript compilers. Now in this course, just like my other courses, I'm going to use Visual Studio Code or VS Code as my code editor. You're welcome to use any editor you prefer, but if you want to follow along and use some of the shortcuts I'm going to teach you, I highly encourage you to use VS Code. In case you don't have it, you can get it from code.visualstudio.com. All right, so go ahead and set up your development environment because in the next lesson, we're going to write our first TypeScript program. All right, now I'm going to go to my desktop folder and create a new folder for our project called hello-world. You can call it anything you want and you can put it anywhere on your machine. Now let's go into this folder and open it with VS Code. So we type code, period. Now if this doesn't work on your machine, you can simply drag and drop this folder onto VS Code. Okay, so here's our project. Now let's add a new file here called index.ts. So every TypeScript file should have the TS extension. Now, earlier I told you that TypeScript is built on top of JavaScript. So we say TypeScript is a superset of JavaScript, which means it has everything in JavaScript plus some additional features. So here we can write any JavaScript code, and that is valid TypeScript code. So we can write console.log and print hello world. Now we can go back to our terminal window here, or we can use the embedded terminal window in VS Code. So back in VS Code, under the view menu, look, we have terminal. The shortcut on Mac is Control and backtick. So we can open the terminal window right here, and using TypeScript compiler, we can compile index.ts. Okay, now let's open our project folder. Look, we have index.js, which is the result of compilation. So we have the exact same code here because in index.ts, we haven't used any TypeScript features. So let's write a bit of TypeScript code. So here in index.ts, I'm going to declare a variable using the let keyword. I'm going to call it age and annotate it with number. So by typing a colon followed by the type of variable, we can annotate or explain a variable. Now we can initialize it to, let's say, 20. Now here's the beautiful part. Because we have declared age as a number, we cannot set it to a string or another type of object. Look, we get this error right here. It's saying type string is not assignable to type number. This is the beauty of using TypeScript. With TypeScript, we can catch a lot of our mistakes at compile time. We don't have to run our application or our unit tests to find that we accidentally set a number to a string. So let's remove this bad line and recompile our file. So back to the terminal, tsc index.ts. Good. Now take a look over here. Look at the JavaScript code that the TypeScript compiler generated. So instead of the let keyword here, we have var, because by default, the TypeScript compiler uses an older version of JavaScript called ES5, which is short for ECMAScript 5. So ECMAScript is a standard or a specification, while JavaScript is an implementation of that specification. So ES5 is an old specification. It's been around for a long time, and all these features have been implemented in our browsers for a very, very long time. I think more than a decade. Now, in the next lesson, I'm going to show you how to configure the TypeScript compiler to target a newer JavaScript version. So the code that will be generated will be more modern. So here's the interesting part. Instead of let, we're using var, and we don't have our type annotation. This is purely for the TypeScript compiler. The actual JavaScript code doesn't specify the type of this variable, okay? So that's it for now. Starting from the next section, we're going to explore TypeScript features in detail. Next, I'm going to show you how to configure the TypeScript compiler. All right, let's talk about creating a configuration file for the TypeScript compiler. So here in the terminal, we run tsc --init. So this created a configuration file called tsconfig.json with these settings. So let's close the terminal window and open tsconfig right here. So in this file, we have a number of settings, and as you can see, most of these are commented out by default. We're only going to use a handful of them. So don't be intimidated by all these settings. You don't have to learn all of them. In fact, nobody knows all of them. I don't know all of them either. Now, in case you're curious, in front of each setting, you can see a description of what that setting is for. So let's talk about a few of them in this lesson. The first one is target, which specifies the version of JavaScript that the TypeScript compiler is going to generate. So this is set to ES 2016, which is an old standard, and it's been implemented in all browsers out there. Now, depending on where you want to deploy your application, you can use a higher target, and that often results in shorter and less concise code. So if you remove this value and press Control and space, we can see all valid values. So we have ES 2015, 16, 17, 18, and so on. Now in this lesson, I'm going to leave this at ES 2016 because this is the safest option for all browser applications out there. But again, depending on where you want to deploy your application and how much of older browsers you want to support, you can use a higher target. Now, the next setting we have here is module, which is set to common.js. We'll talk about this setting later in the course where we talk about modules. Now, in this section, in the module section, we have a setting called root_dir, which specifies the directory that contains our source files. So let's remove the comment by pressing Command and slash on Mac or Control and slash on Windows. So this is set to period slash, which represents the current folder. Now, by convention, we often put our source code into a separate folder. So back to our project panel, let's create a new folder here called src, and then move index.ts right here. Okay. Now I'm going to delete index.js. We don't need it for now. Okay. So now we're going to change root_dir to period slash source. Now we have a similar setting here under the emit section. That setting is called out_dir. And this specifies the directory that will contain our JavaScript files. So let's enable this and change it to dist. So when we compile our code using the TypeScript compiler, our JavaScript files are going to be stored in dist or distributable folder. Okay. Now here we have another useful setting called remove comments. So if we enable this, the TypeScript compiler is going to remove all the comments that we add in our TypeScript code. So the generated JavaScript code is going to be shorter. Okay. Now another useful setting in this section is no emit on error. So by default, when we compile our code, even if we have errors in our code, the TypeScript compiler will still generate JavaScript files. This is probably not what we want. So the best option is to always enable this setting. So if you have any mistakes in our code, the TypeScript compiler is not going to generate any JavaScript files. Okay. Now with this configuration file in place, now we can go back to the terminal and compile our code simply by running tsc without any arguments. So we don't have to type index.ts. We just run tsc, and this will compile all TypeScript files in this project. Take a look. All right. Now we have a new folder called dist that contains our JavaScript file. So this was the basics of tsconfig. As we go through the course, we'll explore more of these useful settings. All right, now let's see how we can debug our TypeScript applications in VS Code. This is very useful when things go wrong and our code doesn't work as expected. So we can run our code line by line and see what exactly happens under the hood. There are a few steps we need to follow. First, we go to tsconfig.json, and here in the emit section, we enable the source map feature. So a source map is a file that specifies how each line of our TypeScript code maps to the generated JavaScript code. Let me show you. So back to the terminal, let's recompile our code. Good. Now look into this folder. We have a new file called index.js.map. This is our source map. So if you look over here, you see some code that specifies how our TypeScript code maps to our JavaScript code. Now, this is not for us to understand. This is for debuggers. It's for machines. Okay. So let's close this file. Now, to make debugging more interesting, let's go to index.ts and write some logic. We can say if age is less than 50, we're going to add 10 to it. Okay. Now we're going to click on the first line to insert a breakpoint. So when we start debugging, the execution stops right at this line, at this breakpoint. From this point forward, we can execute our code line by line. Okay. Now we go to the debug panel and click on create a launch.json file. Now from this dropdown, we select Node.js, and this creates a new file called launch.json in our project. I'll show you that in a second. So this is a JSON file with some configuration that tells VS Code how to debug this application. So we're going to use Node to launch this program. And here we have a label called launch program, which you will see in a second. And we can see our program starts here. So in the source folder, we have index.ts, and our output files are stored in our workspace in our project in files with the JS extension. Now here we need to add one more setting. It's called pre-launch task. We're going to set this to a string with this value, tsc::build space hyphen space tsconfig.json. Make sure to type this out exactly as I've shown you here. All these spaces matter, okay? So with this setting, we're telling VS Code to use the TypeScript compiler to build our application using this configuration file, okay? Now, we go back to index.ts, and to start debugging, we can go to the debug panel and click on Launch Program. This is the label that I just showed you. Now, look at the shortcut. It's F5. I always prefer to use shortcuts. So let's start debugging. Good. Now our program started and the execution stopped right on this line at this breakpoint. Now on the top, we have a bunch of tools for executing our code. We have step over for executing one line. We have step into for stepping into a function. Currently, we don't have any function, so it's not useful. We also have step out. This is useful for stepping outside of a function. We have restart and stop. So in the tooltip that you see in front of each tool, you can see the shortcut. So the shortcut for stepping over a line is F10. Let's press that. So this line was executed. Now on the left side, under variables, you can see all the variables that are detected in this debugging session. So under local, we have age that is set to 20. As we execute each line, you'll see the value of this variable getting updated. Now, if there's something that you don't see in the variables window, you can go to the watch window and insert a watch. So we're going to watch the age variable. Currently it's 20. So let's step over this line. Now we're on this line. So let's step over this as well. Now age got updated, but because our program terminated, we don't see its value anymore. But if you add one extra line here, let's say console.log age. Let's start the debugging session one more time by pressing F5. Now step over F10, 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 and now age is 30. So this is debugging in VS Code. It's very useful when things go wrong. We can start our program and execute it line by line. All right, now that we're done with debugging, we can stop the debugging session right here. So that brings us to the end of this section. Starting from the next section, we're going to explore TypeScript in detail. Welcome back to another section of the Ultimate TypeScript course. In this section, we're going to explore the fundamentals of TypeScript. So you will learn about the built-in types like the anytype, arrays, tuples, enums, functions, and objects. The concepts you will learn in this section will be the foundation for future sections, so don't skip any lessons. Now, let's jump in and get started. So JavaScript has built-in types like number, string, boolean, null, undefined, and object. Now TypeScript extends this list and introduces new types like any, unknown, never, enum, and tuple. As we go through this section, you will learn about all these types in detail. But before we get started, let's see how we can play with primitive types in TypeScript. So back in index.ts, I'm going to delete all this code and declare a variable called sales of type number and set it to a value like 1, 2, 3, 4, 5, 6, 7, 8, 9. So once again, we're annotating or explaining the type of the sales variable using this syntax, okay? Now in TypeScript, if you have a large number, we can separate its digits using an underscore. That makes our code more readable, okay? Now let's also declare a variable called course of type string and set it to TypeScript. And one boolean called is published. Now let me show you something really cool. In TypeScript, we don't always have to annotate our variables because the TypeScript compiler can infer or detect the type of our variables based on their value. For example, because we have initialized this variable to a number, the TypeScript compiler knows that this variable is a number, so we don't have to annotate it. So if we remove the annotation and hover our mouse over this variable, look, we can see that sales is a number. Similarly, because we have initialized course to a string, we can remove the annotation, and once again, we can see that course is a string. And one more time. Now, what if we declare a variable like level and don't initialize it? TypeScript assumes that this variable is of type any. We'll talk about that in the next lesson. In TypeScript, we have a new type called any, which can represent any kind of values. So if we declare a variable and don't initialize it, the TypeScript compiler assumes this variable is of type any. So we can set it to a number, and then later on we can set it to a string. But this is against the whole idea of using TypeScript, because we use TypeScript for type safety, so we get type checking. So if we use the any type, we essentially lose that feature and the major benefit of using TypeScript. So as a best practice, you should avoid using the any type as much as possible. Let's look at another example. Let's say we have a function called render that takes a document and simply renders it on the console. Now look, we have a compilation error, and the error is saying parameter document implicitly has an any type. Implicitly means we haven't explicitly or clearly set the type of this parameter. So the compiler is inferring or guessing the type of this parameter. And that's why we have this error. Now, let's say this is part of a JavaScript project we're trying to convert to TypeScript. And at this point, it's impossible for us to explicitly annotate this with a particular type. So we have to use the any type here. Now here we have two options. To turn off this error, one option is to annotate this with any. So we're telling the compiler, hey, I know what I'm doing. The document is of any type. But what if we have tons of errors of this kind? We don't want to go to every function and explicitly annotate various parameters with any. Well, there is a nuclear option for that, but I don't personally recommend that. But let me show you how that works. So let's remove the annotation. Now, if you're on Mac, press Command and P. If you're on Windows, press Control and P to bring up the search box and go to tsconfig.json. Now look, in the type checking section, strict is turned on, and this is equivalent to turning on some of the basic type checking features. You will learn about these settings as we go through the course. Now, the first setting you see here is no implicit any. So let's remove the comment. So if this feature is turned on, the compiler will complain about implicit any types. Now, let's turn this off and see what happens. So back in index.ts, the error is gone. So use this with caution only if you know what you're doing. Otherwise, there's really no point using TypeScript because you will lose the major benefit of TypeScript, okay? So back to tsconfig, I'm going to revert this code. Good. So that's all about the any type. Next, we're going to talk about arrays. All right, let's talk about arrays. In JavaScript, we can declare an array like this. Now, the thing about JavaScript arrays is that each element can be of different type. So here we can have two numbers followed by a string. And this is totally valid JavaScript code because JavaScript arrays are dynamic, so each element can be of different type. But what if we pass this array to a function that expects a list of numbers? Then the third element is going to cause some issue, right? This is where we use TypeScript. So we can explicitly apply a type annotation here and say numbers is a number array. Now we see the error immediately at compile time. So let's fix it. Good. Now in this particular case, we don't even have to apply the type annotation because every element in this list is a number. So if you remove the type annotation, the compiler can still infer or guess the type of this variable. Great. But what if we had an empty array here? Look, now the type of this variable is any array, which is something we should avoid. With any arrays, again, we can have a mix of different types. So the first element can be a number. The second element can be of a different type, like a string or a boolean. So if you want to use an empty array, you have to explicitly apply a type annotation here. Let's say number array. Now the third line is invalid. So let's delete it. Now let me show you another cool benefit of using TypeScript, and that is code completion or IntelliSense. So if you type numbers.forEach and pass an arrow function here, like n goes to, and then type n period, over here we can see all the properties and methods of number objects. Because our editor knows the type of n, it offers code completion, so we can see all the methods of number objects. This is very useful. It's a great productivity boosting feature. We don't get this with plain JavaScript, right? So that's another benefit of using TypeScript. That's all about the arrays. Next, we're going to talk about tuples. TypeScript has a new type called tuple, which is a fixed length array where each element has a particular type. We often use them when working with a pair of values. For example, let's say for each user, we want to represent two values, an ID and a name. So we declare a variable and annotate it using a special syntax like this. First, we add square brackets and then tell the compiler that the first element is going to be a number, whereas the second element is going to be a string. And then we initialize our variable like this. So we have a fixed length array with exactly two elements, nothing more, nothing less. So if we add a third element here, we get a compilation error saying type number string number is not assignable to type number string. Okay? So exactly two elements, and these elements should have these types. The first one has to be a number. So if we pass a string, again, we get a compilation error. Now, just like before, here we get IntelliSense or code completion. So if we access the first element, we see all the methods of number objects. And if we access the second element, we see all the properties and methods of string objects. Again, one of the reasons I love TypeScript. Now, one thing you need to know about tuples is that internally, they're represented using plain JavaScript arrays. So if we compile our code, we're just going to see a regular JavaScript array. Let me show you. So here in the terminal, let's run tsc. Good. Now, back in our project, here in the dist folder, let's open index.js. Look, we just have a regular JavaScript array. So that means back in our TypeScript code, if we type user period, over here, we can see all the methods of array objects. Now, one of this method is a little bit troublesome, and that is the push method. So we can call this method and store a third value in this array. And the compiler is not going to complain here. I believe this is one of the gaps in TypeScript at the time of recording this. Hopefully, this will be solved in the future. So a tuple is a fixed length array where each element has a particular type. Now, as a best practice, I would say restrict your tuples to only two values, because anything more than that is going to make your code a bit hard to understand. For example, if we add a boolean and another number here, what do these values really represent? It's really hard to tell. So tuples are useful when we have only two values, like key value pairs. Next, we're going to talk about enums. TypeScript has another built-in type called enum, which represents a list of related constants. If you know C# or Java, you have seen enums before. We have the exact same concept here in TypeScript. So let's say we want to represent the size of t-shirts as constants. One way is to define three constants like this: small, medium, and large. That's one way. And then throughout our code, we can reference these constants. Another way is to group these constants inside an enum. So we use the enum keyword, then give our enum a name. Now note that here I'm using Pascal naming convention. So the first letter of every word should be uppercase, okay? Then we add curly braces, and inside the braces we add our members: small, medium, and large. Once again, I'm using the Pascal naming convention for the members. Now when we define an enum, we don't need to define these three constants anymore. And by default, the TypeScript compiler assigns the first member the value of 0, and other members values like 1, 2, and so on. Now, if you don't want to use these values, you can explicitly set values. So we can set small to 1, and then medium becomes 2, and large becomes 3. We can also use string values like s. If we do this, then we have to explicitly set a value for each member. So medium and large, like this. Now I'm going to revert this code and just rely on numbers. So I'm going to initialize small to 1 and rely on the compiler to set the value for other members. So now that we have this new type, we can declare a variable like mySize of type size and set it to size dot medium. Okay? So this is how we can use enums. Now let's see what happens if we log mySize on the console. So back to the terminal, let's run the TypeScript compiler. Good. And then use Node to execute our JavaScript code. So we go to the dist folder and pick index.js. So look, we see the numeric value associated with our enum member, okay? Now let's look at the generated JavaScript code in this file. So back to the project, here's our index file, take a look. So the generated JavaScript code is pretty verbose, it's pretty lengthy. Now you don't need to worry about understanding this, but let me show you a trick. Back to our TypeScript file, if we define this enum as constant, the compiler will generate a more optimized code. So let's recompile our code and then look at index.js one more time. Now we don't see all that code anymore. We only have one line for setting my size to 2. Again, you don't have to worry about the generated JavaScript code. All I want you to take away here is that using an enum, we can represent a list of related constants. And if we define our enums using the constant keyword, the compiler will generate more optimized code. Next, we're going to talk about functions. Let's talk about how TypeScript helps us prevent common problems when working with functions. So let's define a function called calculateTax and give it an income parameter of type number. Now, let's hover our mouse over the function name. Look at the type of the return value. It's void, meaning this function does not return a value. If you return a value here, like a number, now the type of the return value is number. So the TypeScript compiler has inferred the type of the return value for us, and that's great. But as a best practice, we should always properly annotate our functions. So all the parameters as well as the return type should be properly annotated, especially if you're building an API for other people to use. So in this case, to annotate the return type, we go after the list of parameters, add a colon, and specify the return type, like number, or void if we are not going to return a value. So let's add number. Now this has an extra benefit. If you forget to return a value, or if you return a different kind of value like a string, we get a compilation error immediately. So as a best practice, always properly annotate your functions. Now let's temporarily return 0. Okay. Look at the income parameter. This is an unused parameter. Now we have a compiler option for detecting these unused parameters. So let's go back to our tsconfig file. In the type checking section, we have a compiler option called no unused parameters. We have to explicitly turn this on because this setting is not part of strict setting. Now back to index.js. Look, we have a warning saying income is declared, but its value is never read. So let's change this code and say if income is less than 50,000, then we're going to return income times 1.2. Now here we have another compilation error saying function lacks ending return statement and return type does not include undefined. It sounds a bit cryptic, but what this error is saying is that if this condition is true, we're going to return a number. Otherwise, as you know, JavaScript by default always returns undefined from our functions. And undefined is not a number. Now, let me temporarily remove the annotation for the return type. Look, we have no compilation error, but this function has a problem. If the income is greater than 50,000, we're going to get undefined from this function. And this may cause a bug in our application. The good news is that we have another compiler option for detecting these kind of issues, where we forget to return a value. So back to our tsconfig file. Again, in the type checking section, we have a setting called no implicit returns. Again, we have to explicitly turn this on because this is not part of the strict setting. Okay. Now, back to our code. We have a warning saying not all code paths return a value. So now we can fix this problem and say otherwise, if income is greater than 50,000, we're going to return income times 1.3. But again, it's best to always annotate our functions properly to prevent all these issues. So we should always return a number from this function. Now we have another useful compiler setting for detecting unused variables. So if we declare a variable like x and don't use it in this function, this is unused. Now using the TypeScript compiler, we can find these issues in our code. So back to tsconfig. Here is the setting, no unused locals. With this feature enabled, now back to our code, we have a yellow warning saying X is declared, but its value is never read. So now we can delete this and make our code cleaner. So this is the basics of functions. Now let's add a second parameter here called taxYear of type number. Now we have a warning here saying taxYear is declared, but its value is never read. So let's change our condition to if taxYear is less than 2022, then return income times 1.2. So now with these two parameters, if you want to call this function, you have to supply exactly two arguments, nothing more, nothing less. So I'm going to pass 10,000 for the income and 2022 for the tax year. If you add an extra argument here, we get a compilation error saying expected 2 arguments but got 3. If you have been coding in JavaScript for a while, you know that this is valid JavaScript code. So JavaScript doesn't really care how many arguments we pass to a function. We can pass more or fewer arguments than the number of parameters. But TypeScript is very strict about this. So here we should pass exactly 2 arguments. So let's remove that. But what if you want to make this optional? Let's say in some places we want to call this function without supplying the tax year. Well, we can make this parameter optional by adding a question mark right here. Now, we have a compilation error on this line saying object is possibly undefined. So if we don't supply the tax year, by default, undefined will be used. And we cannot compare undefined with 2022. So here we have 2 options. One option is to use the old JavaScript trick. So we wrap this in parentheses, and then using the OR operator, we give it a default value like 2022. So if we don't supply the tax year, this value will be used. Otherwise, the argument that we pass will be used here. Okay? Now, I don't like this approach. There is a better way. We can give this a default value. So instead of making it optional, we give it a default value like this. Now we can call this function with or without a tax year. If we don't supply an argument for the tax year, this value will be used. Otherwise, what we pass here will overwrite the default value, okay? Now, with this default value, we no longer need to use this ugly expression. We can simply compare tax year with 2022. So let's quickly recap what you learned in this lesson. As a best practice, always properly annotate your functions, all the parameters and return types, and enable these 3 compiler options. No unused locals, no unused parameters, and no implicit returns. All right, the last thing we're going to cover in this section is objects. So let's declare an employee object with an ID property. Now, you know that in JavaScript, objects are dynamic, so their shape can change throughout the lifetime of our programs. So once we have an employee object, then later we can give it a new property like name, and this is totally valid in JavaScript. But as you can see, this is not valid in TypeScript. The compiler is saying property name does not exist on this type. So this type is an object with an ID property, which is a number. So just like all the variables we have declared so far, the TypeScript compiler has inferred the shape of this employee object. So if you hover our mouse over employee, we can see its shape. It's an object with an ID that is a number. Now, just like all the variables we have declared so far, we can explicitly apply a type annotation here. So after employee, we add a colon followed by braces, and inside the braces, we define the properties of an employee object. So every employee should have an ID that is a number and a name that is a string. Now the previous error on this line is gone, but we have a new kind of error. Let's find out. The compiler is saying property name is missing. So the reason we're seeing this is because every employee should have these 2 properties, but while initializing this object, we haven't supplied the name property. Now here we have 2 options. One option is to set the name to an empty string. We cannot set it to null or undefined. We'll talk about this in the next section. So we should either set it to an empty string, or we can make this property optional, and then we don't have to supply the name property while initializing an employee. Now, even though TypeScript allows us to do something like this, this is something we should avoid because conceptually, it doesn't make sense to have an employee without a name. Every employee should have a name. it would make sense to make the fax property optional because not everyone has a fax machine, right? So always make sure the code you write conceptually makes sense. Don't blindly use features of TypeScript or any other programming languages, okay? So in this case, we're not going to use an optional property, and that means we should either set the name to an empty string or initialize it right here, okay? Now we have an error because I used a period, okay? So now we don't need this last line anymore, okay? Now, sometimes we want to make certain properties read-only so we don't accidentally change them later on. So with our current implementation, we can change the ID of an employee anytime, and this is not valid. This is where we use the read-only modifier. So we apply it before the name of the property, and now the TypeScript compiler prevents us from accidentally modifying the value of this property, okay? Good. Now, how can we define a function, or more accurately, a method in this object? Let's say every employee object should have a retire method. So in our type annotation, we need to define the signature of this method. We need to specify how many parameters it's going to have, what is the type of each parameter, and what is the type of the return value. So we're going to have a retire method with one parameter, that is date. Now here we use the arrow function syntax. So first we add parentheses, and inside parentheses, we specify the parameters. So we're going to have a date parameter of type date. This is just a built-in date object in JavaScript and TypeScript. So we only have one parameter. Then we use a fat arrow, and here we specify the type of the return value. We don't want to return any value, so we're going to use void. Now, we have a compilation error saying property retire is missing because when initializing this object, we haven't supplied the retire method. So let's do that real quick. All right, retire is going to be a method with one parameter. And over here, I just want to log the date on the console. Pretty simple. So this is how we can work with objects. Now I know this syntax, this type annotation is a little bit messy. It's making our code a bit verbose or noisy. So in the next section, I'll show you a better way to work with objects. Welcome back to another section of the Ultimate TypeScript course. In this section, we're going to explore more advanced types in TypeScript. So you will learn how to use type aliases to reuse types and simplify your code, how to use unions and intersections to combine types, how to narrow types, how to work with nullables, as well as the unknown and never types. So let's jump in and get started. All right, so this is the employee object that we created at the end of the previous section. Now, there are three problems in this implementation. The first problem is that if we want to create another employee object, we have to repeat this structure. We have to repeat this shape. So we'll end up duplicating our code, which is bad. We always want to conform to the dry principle. Don't repeat yourself. Now, the second problem is that the other employee object might have other properties. So these two employee objects might not have a consistent shape because we don't have a single place to define the shape of an employee object. Now, the third problem is that overall, this structure is making our code a little bit hard to read and understand. This is where we use a type alias. Using a type alias, we can define a custom type. Let me show you. So on the top, we start with the type keyword, then give our new type a name. And once again, here we use the Pascal case. So employee with a capital E. Then we set it to braces. And inside the braces, we define all the properties and methods an employee object should have. So I'm going to go in this annotation, select these three lines, and by pressing Alt and up, we can move these lines up, okay? Now, when defining this employee object, we annotate it with our new type, employee, okay? So now we have a single place where we define the shape of an employee object, and we can reuse this in multiple places. This is the benefit of using a type alias. All right, let's talk about union types. With union types, we can give a variable or a function parameter more than one type. So let's define a function for converting weight from kilogram to pounds. Now we give it a parameter called weight. Now let's assume that this parameter can be either a number or a string. So we annotate it with number or string. So using a vertical bar, we can create a union type. Now, we can call this function in two ways. We can give it a number or a string like 10 kilograms. Okay? Now, let's finish up this example. So we're going to annotate the return type and return a number. Now, in this function, at this point, we don't know if the weight is a number or a string. So if we type weight period, we only see the properties and methods that are common between numbers and strings. So both numbers and strings have these three methods: toLocalString, toString, and valueOf. So here we are not seeing methods that are specific to numbers or strings. And this is where we use a technique called narrowing. So we're going to narrow down this union type into a more specific type. So here we can say if type of weight equals number. Now in this block, the compiler knows that the weight is a number. So if we type weight period, we see all the methods that are available in number objects. And by the way, we don't necessarily need the code blocks here. In this line, if you have a one-liner and type weight period, we still see all the methods available in numbers. Okay? So what are we going to do here? We're going to return weight times 2.2. Otherwise, if we end up here, that means weight is a string. So now we see all the properties and methods of string objects. Okay? So to finish this example, here we're going to return. First, we need to convert the weight to an integer. So we call parseInt, pass the weight, and then multiply it by 2.2. Okay? Now back to the terminal, let's compile our code and see what we get. All right, we're going to go to index.js. Take a look. Our union type is not part of the generated JavaScript code. It's purely for the compiler to do its type checking. So in the previous lesson, you learned that using a union type, we can say a variable or a function parameter can be one of many types, right? Now we have another technique for combining types called intersection. So instead of a vertical bar, use an ampersand. And now this type represents an object that is both a number and a string at the same time. Now technically, this is impossible. We cannot have an object that is both a number and a string at the same time. So let's look at a more realistic example. I'm going to use our type alias to define a new custom type called draggable. So this represents an object that can be dragged on the screen. Now, what properties or methods do we need in a draggable object? Well, at least we need a method called drag, which takes no arguments and returns void. Now, similarly, we're going to define another type called resizable. And here we need a resize method that should take two parameters like the new width and the new height. But for simplicity, let's get rid of all that noise and just add no parameters and say this method returns void. Okay? So now we have two separate types, and using an intersection type, we can combine them into a new type. So we can define a new type called UIWidget, which is draggable and resizable. So this is an intersection type. Now with this type in place, we can declare a variable called textbox, which is a UI widget. Now to initialize this object, we need to implement all members of draggable and resizable objects. So we need to implement the drag and resize methods. So drag is a simple method, and so is the resize method. So this is type intersection in action. Sometimes we want to limit the values we can assign to a variable. This is where we use literal types. So let's declare a variable called quantity and assume that the quantity can either be 50 or 100, but nothing else. Now here's the problem. If we annotate this with number, this can take any numbers, any valid numbers in JavaScript, right? So to limit the values we can use here, we use a literal type. So instead of annotating this with a type like number, we'll annotate it with a literal, meaning an exact or specific value. So I'm going to replace number with 50. Now quantity can only be set to 50, nothing else. So if we set it to 51, you get a compilation error. Now you might think this is not useful. Well, that's true. But what if we apply the union operator here? So we can say the quantity can be 50 or 100. Now we can set it to 50 or 100, right? But we're not done yet. We can make this code even better. So instead of hard coding these literal values here, we can create a custom type using a type alias. So we define a new type called quantity, which can be 50 or 100. And then we annotate our variable with our new type. So what we have over here is called a literal type. Now, literals don't have to be numbers. They can also be strings. For example, we can define a new type called metric, which can be centimeter or inch. Okay? So that's all about literal types. Next, we're going to talk about nullable types. All right, let's talk about working with null values. So by default, TypeScript is very strict about using null and undefined values because, as you probably know, these values are a common source of bugs in our applications. So let's look at a real example. Let's define a function called greet that takes a name, which is a string. Now in this function, we just want to do a console.log and print name.toUppercase. Now in vanilla JavaScript, we can call this function and accidentally give it null or undefined. That is totally valid JavaScript code. But when we run our program is going to crash because we cannot call this method on a null or an undefined object. So this is why null and undefined values are a common source of problems. And that's why, by default, the TypeScript compiler stops us from using null or undefined values. So here we have an error saying argument of type null is not assignable to parameter of type string. Let me show you where this comes from. So let's go to our tsconfig file. In the type checking section, we have a compiler option called strict null checks. Now this is enabled by default as part of the strict option. So if strict is set to true, strict null checks is also true. But we can overwrite it and turn off this feature. Now, back to index.ts, the error is gone. So this is why, by default, TypeScript is very strict about using null values. So technically, we should never use this option. We should never turn it off. So I'm going to revert this back. But what can we do in this function? What if we want to have the ability to use a null value? Perhaps if we don't have a name, we want to print just a generic message like hola, meaning hi in Spanish. So here we can say if name is truthy, meaning it has a value, then we're going to print name.toUppercase. Otherwise, if it's null or undefined, we're going to print hola, okay? But we cannot pass a null value here. This is where we use a union type once again. So we annotate this parameter with string or null. Now we can pass a null value, but we cannot pass undefined because this is not a valid value for this parameter. So if you want to have the ability to pass undefined as well, again, we're going to use the union operator. Now, when working with nullable objects, we often have to do null checks. For example, let's define a type alias called customer and give it a birthday property of type date. Now let's define a function for getting a customer from a database. So we give it an ID, which is a number, and we get either a customer or null in case there is no customer with the given ID. Now in this function, let's write some basic logic like return if ID equals 0, then we return null, otherwise we return a customer object with this birthday. Pretty simple. Now let's declare a variable, and here we call getCustomer and pass 0. Now let's imagine we want to print the customer's birthday. So console.log, and here we pass customer.birthday. Now here we have a compilation error because customer might possibly be null. So as you know, one way to solve this problem is like this. We check if customer is not null, then we execute this piece of code. Now let's take this to the next level and assume that under certain circumstances, this function might return undefined. So we add undefined here. And now we have to expand this if statement and check for undefined. So if customer is not null and it's not undefined either, then we print the customer's birthday. That works, but there is a simpler way to write this code in TypeScript. We can remove this if statement and use what we call the optional property access operator. So because customer might be null or undefined, right after it we add a question mark and then we add the chaining or the dot operator. So this question mark followed by the chaining operator is called the optional property access operator. So now this piece of code gets executed only if we have a customer that is not null or undefined. Let's see this in action. So we're passing 0 and we get a null object. So if we execute this code, we get undefined. So the result of this expression is undefined. But if we pass 1, we get an actual customer object. So we'll see the customer's birthday on the console. There you go. Okay. So this is optional property access operator. Now we can take this to the next level. Let's make the birthday property optional. Now let's say we want to print the full year of the birth year. So over here, we have to call dot get full year. Now, once again, we have the same compilation error because the birthday property might possibly be undefined. Once again, to solve this problem, we can use the optional property access operator. So now this piece of code gets executed only if we have a customer and that customer has a birthday. Otherwise, the result of this expression is undefined. Okay. Now we also have what we call optional element access operator. And this is useful when we are dealing with arrays. So we might have an array of customers and we want to print the first customer on the console. Now, if this array is going to be null or undefined, of course, we have to check if customers is not null and it's not undefined, then we're going to access the first element. Now, this is where we can use the optional element access operator. So before accessing this element, we use a question mark and a dot. Okay. Now we also have the optional call operator, which has the exact same syntax. So let's imagine we have a variable called log, which is going to reference a function. So for simplicity, I'm going to annotate this with any, and this might be set to a function, like a function that takes a message and prints that message on the console, or we might set this to null, right? Now, let's say we want to call this and pass some value. If we run this program, our program is going to crash because log is null. So this is where we can use the optional call operator. So this piece of code will get executed only if log is referencing an actual function. Otherwise, we'll get undefined. When working with null or undefined values, sometimes we need to fall back to a default value. For example, let's declare a variable called speed of type number or null. Let's imagine that we received this from the user. For now, I'm going to initialize this to null, meaning the user didn't provide a value for the speed. So we get the speed and then we create a write object. Now we could annotate this with a proper type, but let's not worry about it at this point. We just create a write object and set the speed to either the value we received from the user or a default value. In plain old JavaScript, we can implement this by saying speed or 30. So if speed is truthy, we're going to use that value. Otherwise, if it's falsy, we're going to use 30 as a default value. Now, I have a question for you. What are falsy values in JavaScript? We have undefined, null, empty string, false, and 0. Now, what if 0 is a valid value for the speed? With our current implementation, if the user enters 0, 0 is going to be ignored because it's a falsy value, and we're going to use 30. So a more accurate way to implement this scenario is by checking for null. So we can check if speed is not null, then use speed, otherwise use 30. Now in TypeScript, we have a better way. We can simplify this expression to speed double question mark 30. What you see here is called the nullish coalescing operator. So the reason this is called nullish is because this value can be null or undefined. So with this, we're saying if speed is not null or undefined, use that value. Otherwise, use 30 as a default value. Sometimes we know more about the type of an object than TypeScript. Here's a real example. In JavaScript, we have this document object that represents a document or an HTML page loaded in the browser. Now, in this object, we have a method called getElementById for getting a reference to an element on this page. Now, look at the signature of this method. Here we have one parameter called elementId, which is a string, and the method returns either an HTML element or null. So nothing new so far. So let's imagine on this HTML page, we have an input field called phone. So we pass that as a string and then get a reference to that input field. So let's store it in a variable called phone. Now let's look at the type of phone. It's either an HTML element or null in case that element was not found. But let's imagine that we do have an element by this name. So the type of phone is definitely HTML element. Now HTML element is a class defined in JavaScript that represents any kind of HTML elements. It's like the base or parent class for other types of elements. So we have more specific elements like HTML, input elements, and so on. Now, elements of this type have an extra property called value for reading the value entered by the user. However, if we type phone.value, we cannot see that property. Yes, we have other properties like ARIA_VALUE_MAX, ARIA_VALUE_MIN, and so on, but none of these properties represent the value entered by the user. This is where we use a type assertion. So we're going to tell the TypeScript compiler, hey, I know more about the type of this object than you. So after this expression, we type as, and then specify the target type, HTML input element. Now, the type of phone is HTML input element. And if we type phone period, we can see the value property. So this is type assertion in action. Now, in some other programming languages like C#, we also have the as keyword, but the as keyword functions differently in those languages. In TypeScript, the as keyword doesn't perform any type conversion. So it's not going to convert the object that is returned from this method to a different type of object. This is purely for telling the compiler that we know more about the type of this object. So if the object that is returned from this method is not an HTML input element, this line is not going to raise any exceptions. And instead, when we try to access this property, the value property, our program is going to crash. So be aware of this. There is no type conversion happening under the hood. Now, there is another syntax to use a type assertion. So instead of using the as keyword, we prefix this expression with angle brackets, and here we add the target type, HTML input element. Earlier in the course, we talked about the anytype, which represents any kind of value. And I told you that we should avoid using it as much as possible. But let's say we're converting some JavaScript code to TypeScript, and we have a situation where we really have to use the anytype. So let's define a function called render that takes a document. Now, the compiler is complaining about the type of this parameter. So to make it silent, we use the anytype. Now, there is a big problem with the anytype. Here we can call document.move, we can call document.fly, we can call document.whatever we want, and there is no type checking done. So if we run our application and there is no move method on this document object, our program is going to crash. This is where we use another similar type called unknown. So if we change the type of this parameter from any to unknown, we immediately see these compilation errors. So the TypeScript compiler is saying, object is of type unknown. So the compiler doesn't know about the type of the document. It doesn't know if there is a move, fly, or other methods on this object. Now, this is where we use type narrowing. Remember, we talked about narrowing early in the course. So by using a type guard, we can narrow down the type of an object and get more specific. So here we can use a type guard like if type of document equals string. Now, in this block, we have access to all string methods. So if we type document.toUppercase, we don't get a compilation error because the compiler knows that this document is a string object. Now, this type of operator only works for primitive types like string, boolean, number. If you have custom objects created with classes, we have to use another operator called instance of. So we can say document instance of, and then here we add our custom type like Word document. We'll talk about this operator in the next section where we talk about classes and interfaces. For now, all I want you to take away is that using the unknown type is preferred to using the any type because the compiler forces us to do some type checking to make sure the methods we're calling exist on the target object. All right, the last thing we're going to cover in this section is the never type, which represents values that never occur. Quite frankly, it's not a type used that often, but let's look at a couple of examples. So let's define a function called process events. Now let's say we want this function to run continuously and process a bunch of events. Perhaps it's constantly watching a message queue, waiting for the next event. So here we can implement an infinite loop like this. And inside this loop, we can read a message from a queue. Now the detail of this is irrelevant. We don't care about that. What matters is that if we call this function and then right after we do something else, let's say print something on the console, you know that this line will never get executed because this function never returns, because here we have an infinite loop. Now this is where we can annotate the return type of this function with never to tell the compiler that this function never returns. Now look at the last line. It's grayed out, meaning it's not going to get executed. But there's more to this. Let's go to our tsconfig file. Once again, in the type checking section, we have a compiler option called allow unreachable code. So let's uncomment this line and turn off this feature. So we're not going to allow unreachable code. Now back in index.ts, look, now we have a compilation error saying unreachable code detected. So this is the benefit of using the never type. Both developers and the compiler can reason about sections of code that are unreachable. Now let's see what happens if we remove the annotation. So we remove it and let the compiler infer the return type. Look, the return type is void, and now this line appears to be reachable, whereas it's not. So this is where we should use the never type. Okay, now let's look at another example. I'm going to define another function called reject that takes a message of type string. And here we always throw a new error. Again, we have a function that will never return. It always throws an error. So if we call this function over here, reject with some message, this line will throw an exception and the last line will never get executed. But we don't see that here in code because by default, the compiler infers the return type as void. But if we annotate this function with never, now we can see that the last line will never get executed. So this is the never type. As I said, it's not something that we use that often, but be aware of it. And that brings us to the end of this section. In the next section, we're going to talk about classes and interfaces. Welcome back to another section of the Ultimate TypeScript course. In this section, we'll be talking about object-oriented programming with TypeScript. We'll start this section by a quick introduction to object-oriented programming. Then we'll talk about creating classes, which are the building blocks of object-oriented applications. You will learn all about creating constructors, properties and methods, access control keywords, getters and setters, static members, and creating dynamic properties using index signatures. Then we'll talk about inheritance, which is a technique for reusing code. Next, we'll explore a powerful technique called polymorphism, and we'll finish this section by exploring abstract classes and interfaces. So there's a lot we're going to cover. Now, let's jump in and get started. So what is object-oriented programming? Well, object-oriented programming is one of the many programming paradigms or styles of programming. We have many paradigms like procedural, functional, object-oriented, event-driven, aspect-oriented, and so on. These programming paradigms are styles or ways of writing code. They are not programming languages. Different programming languages support different programming paradigms. For example, JavaScript and TypeScript both support some object-oriented and functional programming techniques. In object-oriented programming, objects are the building blocks of our application. So a real application consists of hundreds or even thousands of objects working together to solve problems. An object is a unit that contains some data, also called state, and operations, also called behavior. For example, we can represent a person as an object. In this object, we can store some data like the person's name, email, and so on. These are the properties of a person object. They are like variables that only exist inside a person object. Now, in this person object, we can also have some operations or some behavior like talk and dance. These are essentially functions inside a person object. In object-oriented programming, we refer to these functions as methods. So a method is a function inside an object. Similarly, in a real application, we can have an object representing a login form, as well as objects for authenticating users, sending emails, and so on. So each object is responsible for a single task, kind of like how people work together in the real world. For example, in a restaurant, we have different people, each responsible for a single task. We have a hostess, a chef, a server, and many other roles, right? So that's the idea of object-oriented programming. Now, object-oriented programming is often compared with functional programming, which is a completely different style of programming. So in functional programming, functions are the building blocks of our applications, and for that reason, our code would end up looking different. Now, some people, like our famous old John Smith, hate object-oriented programming and are obsessed with functional programming. So they try to solve every single problem using functional programming. Don't be one of them. Remember, every programming paradigm or every tool in general has some strengths and some weaknesses. So there is no such a thing as the best tool, the best language, or the best programming paradigm in the world. So please, for God's sake, stay away from these arguments about functional versus object-oriented programming. And more importantly, don't fall in love with just one tool and try to solve every single problem using that tool. So in this section, we'll be exploring the fundamental object-oriented programming techniques, but I gotta tell you, that's just the tip of the iceberg. There is way more to object-oriented programming than we can cover in this course. If you really want to understand object-oriented programming, I have a 3-part course called Design Patterns that teaches you how to solve real coding problems using object-oriented programming techniques. In this course, I've used Java, but you can still follow along because the syntax or the grammar of TypeScript is almost identical to Java. So you don't need to learn Java just to take that course. All right, that's it for now. Next, we're going to talk about creating classes in TypeScript. So object-oriented programming is all about objects. Now, to create an object, first we need to create a class. A class is a blueprint for creating objects. It's like an object factory. So let's say we want to represent the concept of a bank account. So we need a class for that. Now in this class, we can have properties like ID, owner, and balance, and methods like deposit and withdraw. So let's implement this class in TypeScript. We start with a class keyword, then give our class a name, like account. And once again, note that here I'm using the Pascal naming convention. So we capitalize the first letter of every word, okay? Then we add braces. Now here we define our properties. So we have ID, which is a number. Then we terminate this line using a semicolon. Similarly, we have owner, which is a string, and balance, which is a number. Now here we have a few compilation errors. Let's take a look at one of them. So the error is saying property balance has no initializer and is not definitely assigned in the constructor. Basically, the error is complaining that this property is not initialized. So to solve this problem, here we need to create a constructor. A constructor is a special function or a special method inside a class that is used for initializing an object. So we start with constructor. Now, just like defining a method, here we add our parameters. So here we need 3 parameters. ID, which is a number, owner, which is a string, and balance, which is a number. Now, this method cannot have a return type annotation because it should always return an instance of a bank account. So if we add braces here and hover our mouse over constructor, look, this constructor always returns a bank account, okay? Now, in this method, we type this to reference the current class. Then we type a period, and now we can see all the properties we defined earlier. So we set ID to the ID that we received over here. Similarly, we set this.owner to owner, and this.balance to balance. So this is how we can initialize our properties. Now, in this class, we can also have methods. So let's implement the deposit method. So after the constructor, we add deposit, which takes an amount, which is a number, and returns void. So we're defining a function, but this function is called a method because it's inside a class, okay? Now, in this method, we can have some logic like if amount is less than 0, or even less than or equal to 0, then we're going to throw a new error and say invalid amount. Otherwise, if the amount is correct, we're going to take that amount and add it to the balance. So we say this.balance plus equal amount. Okay, so this is how we can create a class in TypeScript. Once we have a class, we can create an object using that class. And we're going to talk about that in the next lesson. But before we get there, let's quickly compile our code and see what we get. So here in the terminal, let's run tsc. Good. Now let's look at index.js. All right, look, we have a class called account, but in this class, we don't have any properties. So the properties that we defined over here are only for TypeScript. They don't exist in JavaScript. In JavaScript, we only have this constructor for initializing these properties. And obviously, we don't have any type annotations. So we don't see the type of these properties or the annotations for the deposit method. Everything else is exactly the same. So this was our first class. Next, I'm going to show you how to create an object using this class. So we created the account class. Now to create an object, we go after this class and declare a variable called account and set it to a new instance of the account class. So using the new operator, we can create an instance or an object from an existing class. Then we open parentheses, just like calling a function. Now look, what you see here is our constructor. So here are the parameters we defined earlier, ID, owner, and balance. So let's pass some values here for initializing this bank account. Mosh as the owner and 0 for the balance. So now we have an object. Now to use this object, we type account period. And here we can see all the members or all the properties and methods of this object. So we have balance, deposit, ID, and owner. Now the members with the blue icon are the properties, and the members with the purple icon are methods, okay? So here we can call the deposit method and deposit $100 in this account. And of course, if we pass a negative value, we're going to get an error. So let's deposit $100 and then log account.balance. Now here in the terminal, let's compile our code and then run it using Node. So Node dist/index.js. Good. So we can see our balance. Perfect. Now let's see what happens if we print the account object itself. So back to the terminal. Now here we can combine these two commands in one step. So we type tsc $&, then node dist/index.js. I'm not entirely sure if this works on Windows, so if it doesn't, please excuse me. You have to do your own research to find how to combine two commands on Windows. Let's go ahead. So here we can see all properties of our account object. We have ID, owner, and balance. Beautiful. Now earlier we talked about the type of operator. So we used that when we talked about unions. Remember, I talked about narrowing down a union using a type guard. So we had some code like if type of some object equals number, then we had some code after, remember? Now let's see what happens if we print type of this account. So back to the terminal, let's go ahead. We see object. So the type of operator always returns object no matter what the underlying class is. So whether our object is an instance of a bank account or a person or a customer, we always see an object. But what if we want to check the type of an object and see if it's an instance of a given class, like account or person. Then we need to use the instance of operator. So here we type account, instance of account. Now what we have here is a boolean expression, so it produces a boolean value. Now let's run our program one more time. We get true. Great. So if you're using a type guard to narrow down a type and you're dealing with a custom object, you should always use the instance of operator instead of type of, okay? Next, we're going to talk about read-only and optional properties. In TypeScript, we have modifiers that we can apply to our properties, and this helps us write more robust code. For example, let's say the ID of a bank account should never change. With our current implementation, we can change the ID of a bank account anywhere in our code. For example, we can go in our deposit method and accidentally set this.id to 0. And this may create a bug in our program. Now, similarly, we can go outside of this class, and where we create an object, we can set account.id to 0. Again, something that should never happen. Now we can solve this problem using the read-only modifier. So on the top, we prefix this property with the read-only keyword. Now we can only set it in the constructor, and if we try to reset it anywhere else, we get a compilation error. So here the error is saying cannot assign to ID because it's a read-only property. Good. Now let's remove this line. Now let's define a new property called nickname of type string. Now we have a compilation error because we haven't initialized this property. But let's assume that not every bank account can have a nickname. This is an optional name or an optional label that the user attaches to their bank account. So we don't want to initialize it in the constructor. Now, what can we do? We can make this optional by appending a question mark here. Now the error is gone. So this is all about read-only and optional properties. In the next lesson, we'll talk about other modifiers we can apply to our properties to write more robust code. In TypeScript, we have other modifiers for controlling access to properties and methods. And again, we use these properties to write more robust code. So let's look at a real example. In our current implementation, we have the deposit method for updating the balance. Now, let's say in the future, we also want to record transactions in this account. So every time we deposit or withdraw money, we want to record a transaction so we know who paid how much when, okay? So we're going to have a new property in this class called transactions, which is going to be an array of transaction objects. Then every time we want to update the balance, just before doing so, we're going to record a transaction object, okay? Now, there is a problem with this implementation. The problem is that once we have an account object, we can directly update its balance. Why is this a problem? Because with this line of code, we don't have a record of a transaction. We don't know who paid how much money when. This is where we can use access control keywords or access modifiers to solve this problem. In TypeScript, we have 3 access modifiers: public, private, and protected. We'll talk about protected later in this section. So for now, let's just focus on public and private. Now, when we declare properties, all these properties are public by default. So we don't have to use the public keyword right here. But if we use the private keyword, look, now we get a compilation error saying property balance is private and only accessible within class account. So we cannot access this property from outside of the account class, but we can access it from within this class inside the deposit method. This is the benefit of using a private property. Now, a common misconception by a lot of beginners is that we use private properties for storing sensitive data like user's password, credit card number, and so on. Don't ever do this. We only use private properties for writing robust code because this private modifier enforces some rule in our code, okay? Now, by convention, we prefix these private properties with an underscore. So let's press F2 here and rename this property to underline balance. That's better. So now we cannot access the balance property, but what if you want to show the balance to the user? if we type console.log account.balance, this doesn't work. So how can we solve this problem? Well, here's one simple solution. In this class, we can define a method called getBalance, which returns a number. And here we return this.underline_balance. Then we call this method right here. Now, there is a better way, which we'll talk about soon. Now, these access modifiers can also be applied to methods. For example, in this class, let's define a method called calculateTags. Let's say we're going to use this method only internally within this class. Perhaps we're going to call it from the deposit method. So we don't want to make this accessible from the outside. So now we can apply the private keyword here. And with this, if we type account dot, we cannot see the calculateTags method. Okay. So this is all about access modifiers. Next, we're going to talk about parameter properties. Let me show you a cool feature of TypeScript that helps us write more concise code. So here we have a constructor with 3 parameters and 3 lines of code for initializing the related properties. So every time we create a class in TypeScript, we have to repeat this pattern. We have to create a constructor with a bunch of parameters and write the property initialization code in that constructor. This is very repetitive. Let me show you a better way. Over here, when we declare this parameter, we can prefix it with an access modifier like public or private. And this tells the compiler to create a property by this name and initialize it in one go. So now we can comment out this line and the initialization code. The compiler will do this for us. There's just one thing. Over here, we declared this property as read-only. So we need to add the read-only modifier after the access control modifier. Okay? Now, similarly, we're going to make owner public. And with this, we can remove this line and the initialization code. And lastly, the balance. The balance is going to be private and we're going to call it underline balance. So let's comment out this line and this line as well. Now let's remove all this unnecessary code. So going forward, this is the syntax we're going to use for creating constructors. It's much more concise. Now, this line is getting a little bit too long, so let's break it down into multiple lines. So always pay great attention to formatting your code so both you and other people can easily read your code. So here we can put each parameter on a separate line, and this makes our code much more readable. Great. So these are called parameter properties. Next, we're going to talk about getters and setters. So earlier we implemented this method for getting the balance. And I told you that there is a better way. Now, don't get me wrong. This solution is perfectly fine, but I don't like the fact that we are calling a method here. Wouldn't that be nicer if we could code like this? So we would access the balance property just like before. This is where we use getters and setters. So look, earlier we renamed this private property to underline balance. So now we can put the cursor here, press F2, and rename this method to balance. And then we apply the get keyword just before it. Now what we have is called a getter. So a getter is a method inside a class that we use for getting the value of a property. Now with this syntax, we can access the balance property just like before, but we cannot set it. So if we try to set account.balance to some value, we get a compilation error saying cannot assign to balance because it's a read-only property. Now, in this case, we don't really want to assign directly to balance because, as I said before, the balance should only be updated as part of depositing or withdrawing money. But let's say in some situations, we want to implement a setter where we get a value and validate it. So let me show you how to implement a setter here. So we start with a set keyword. Then we give our method a name, just like before, balance. Now this method should get some value, which is going to be a number. And in this method, we can do some validation. For example, we can say if value is less than 0, throw new error, invalid value. Otherwise, if the value is correct, then we can set this underline balance to this new value. So we have a getter for getting the value of this private property, and a setter for setting its value. Now with this syntax, we can work with this property just like before, but we are not assigning directly to our private property. So anytime we assign a value to this property, this setter gets called, and this is our chance for validating data. Now again, in this case, we don't want to have a setter, so I'm going to delete this method. Okay, so this is all about getters and setters. So you know that in JavaScript, we can create an object and add properties to it dynamically. But this is not possible in TypeScript because TypeScript is very strict about the shape of objects. But there are situations where we need to add properties to an object dynamically, and this is where we use index signatures. So let's say we're building a ticketing application for concerts, and for each concert, we want to know who is sitting where. So we start by creating a class called seatAssignment. Now, in a venue, we can have seats like A1, A2, and so on. And we want to know who is sitting on each seat. So we can say Mosh is sitting on A1, John is sitting on A2, and so on. Now, we don't want to define individual properties like A1, A2, and so on here, because first of all, this is very repetitive. What if we have 100 or 1,000 seats in a venue? We are not going to define 1,000 properties here, right? Also, what if in another venue, our seats are numbered differently? So we don't have A1, A2, we have some other numbering system. So this is where we use index signatures for creating properties dynamically. So look, instead of typing the name of a property like A1 or A2, we add square brackets, give our property a name like seat number of type string. Why am I using string here? Because we can represent the property name like A1 or A2 as a string, okay? Now, what kind of value can we store in this property? In this example, I'm using strings, so we can store a string like Mosh Hamedani, but we can store anything here. We can store a person or a customer object, okay? So for now, let's just set the type of this property to string. Now let's remove these individual properties. So what we have here is called an index signature property. It's a special kind of property. Now let's create an object. We can call it seats. And with this, we can set seats.a1 to Mosh, seats.a2 to John, and so on. Okay? Now, in JavaScript and TypeScript as well, we have another way to access a property. So here we're using the dot notation, but we can also use the square bracket notation. So we can say seats, square brackets, a1 equals Mosh. So these two lines are identical, okay? So using index signatures, we can create properties dynamically, just like JavaScript, but we also get type checking, we get type safety. So we know that in our current declaration, we can only store string values in these properties. So if I try to set A2 to a number, I get a compilation error. So that's all about index signatures. Next, we're going to talk about static members. Now, let's imagine we're building a ride-sharing application like Uber, so people can use their phone and request a ride. So we create a class called ride. Now, in this class, we can have properties like passenger, as well as pickup, location, drop-off, location, and so on. But let's not worry about these properties and talk about keeping track of the active rides. So we want to know how many active rides we currently have in our system. So we define a property called active rides of type number. Now we get a compilation error because we haven't initialized this property. So here we can create a constructor, or we can initialize this property directly here. Good. Now in this class, we're also going to have methods like start and stop. So this is where we increment this.activeRides, and stop where we decrement this.activeRides. Great. So we have a ride class. Now let's create two rides. So ride one, it's going to be a new ride. And here we call ride1.start. Now I'm going to duplicate these two lines and change ride1 to ride2. Okay? Now finally, let's log the number of active writes on the console. So log write1.activeWrites and write2.activeWrites. Great. Now here in the terminal, let's compile and run our program. So we see 1, but we currently have 2 active writes. Why is this happening? Well, here we're dealing with 2 separate objects, write1 and write2, and each object is in a separate space in memory. So each object is independently tracking the active writes. That is why we have this issue. What we need here is a single or global place where we can keep track of the active writes. And this is where we use static properties. A static property is a property that belongs to a class and not an object. So we're going to have only one instance of that property in memory. So on the top, where we define our property, we're going to prefix this with static. Now this property belongs to the write class and not a write object. So down below, look, when we try to get write1.activeWrite, we get a compilation error saying property activeWrite does not exist on type write. Did you mean to access the static member write.activeWrites instead? That is correct. So we're going to replace write1 with the write class and one more time. Yeah, these 2 lines are the same, so I'm going to delete one of them. So now this property belongs to the write class, and that is why we also have 2 compilation errors, because in the start method, this references the current object, but an instance of the write class does not have a property by this name. So once again, we need to replace this with write. Okay? Now let's run our program one more time and see what happens. Okay, we see 2 active writes. Beautiful. So this is how static properties work, but there is a problem in this implementation. The problem is that anywhere in this code, I can directly modify write.activeWrites. So I can set it to 10, and this is going to create a bug in our program, right? So once again, we're going to use access modifiers. So we're going to make this private so we cannot access it directly. And then we're going to create a public getter for reading its value. So in this class, we're going to define a getter called activeWrites. Now I forgot to rename this property to underline activeWrites. Good. Now this is our getter. So it's going to be a method that returns write.underline activeWrites. Okay. Now this method, this getter is currently part of a write object. That's why we have a compilation error here saying property activeWrites does not exist on type write. So to move this to the write class, we have to prefix this with the static keyword as well. Now let's look at the error one more time. This time the error is saying cannot assign to activeWrites because it's a read-only property. Great. So now this can prevent us from accidentally creating bugs, and we have a single place where we can keep track of the active writes. So when we make a property or a method static, that property or method becomes part of a class and we'll have only a single instance of them in memory. Sometimes we deal with classes that have some commonality. For example, both student and teacher can have common properties like first name, last name, and full name that combines the two, as well as methods like walk and talk. Now, we don't want to write this code in 2 separate places, once in the student class, once in the teacher class, because duplication in code is bad. It's better to write this code once and reuse it in many different places. And this is where we use inheritance. So we extract these common properties and methods and put them in a separate class like person, and then have student and teacher inherit these commonalities. This is inheritance in object-oriented programming. So inheritance is a mechanism that allows us to reuse our code. Now in this scenario, we refer to the person class as the parent or the base or the superclass, and student and teacher classes, we refer to them as child, derived, or subclass. Different people use different terms to refer to the same concept. So let's see this in action. We start by creating the person class. Here we create a constructor with 2 parameters. First name of type string and last name of type string. Now here we need a getter called full name for combining the first and last names. So get full name, and here we return this dot first name plus a space and this dot last name. Now here we can have other methods like walk and talk. So let's implement one more method, walking. Okay. So here's our person class. Now let's create the student class. So right after the person, we create another class called student. And here we use the extends keyword to tell the student class inherit everything from the person class. Now a student can have additional properties and methods. For example, every student can have a student ID. So let's create a constructor and give it a parameter, public student ID of type number. Now, here we have a compilation error saying constructors of derived classes must contain a super call. So in TypeScript, we have a special keyword called super that we use to reference the base class. So here we type super followed by parentheses to call the constructor of the base class. Now here we need a first and last name, and that means we need to add these parameters in this constructor as well. So public first name of type string and public last name of type string. Now earlier I told you that when we use an access modifier like public or private here, we're essentially creating a parameter property. So the TypeScript compiler will create a property by this name and initialize it for us. Now, in this case, we don't want to use the public modifier here because we already created these properties in the person class over here. Okay, so let's simplify our code and remove the public modifier. We only need it for the student ID, which is a property specific to this class. Okay, now here we call super and pass first and last names. Good. Now in this class, we can have additional methods like take test. And here we just log taking a test. Okay. So this is inheritance. Now let's create a student object. So let's create a student object, new student. And here we pass one for the student ID and John at gmail.com. Now, let's type student period. Look, we have inherited first name, full name, and last name from the base class. And we also have student ID that we implemented in the student class. Now, similarly, we inherited the walk method from the base class, but we also implemented an additional method in the student class. This is the benefit of using inheritance. Now, one last thing before we finish this lesson. In this example, I implemented both these classes in the same file, but as a best practice, we should implement each class in a separate file. We're not going to do that yet because first we have to talk about modules so you understand how modules work before you can move your classes to separate files. So inheritance is great, but sometimes we want to change something in the inherited code. For example, look at the full name getter in the person class. Let's say we're going to implement the teacher class, and when getting the full name of a teacher, we want to prefix their name with professor. So in the teacher class, we want to change the implementation of the full name getter. This is called method overriding. So overriding a method means changing its implementation. Let me show you how to do this. So down the bottom, we don't need the student object. Instead, we're going to create the teacher class. So class teacher extends person. Now at this point, I don't want to add any extra properties in this class, so we don't need to create a constructor. And that means we're going to inherit the constructor of the person class. So right here, we can create a teacher, new teacher, and now we see the constructor of the person class that we have inherited. So let's pass some values like John Smith. Now we do a console.log and print teacher.fullname. Now if you run our program, obviously we see John Smith, but we want to change the implementation of the full name getter and prefix the name of the teacher with professor. So back to the person class. To save time, I'm going to copy the full name getter, and then paste it in the teacher class. Now here we need to prefix this with the override keyword to tell the compiler that we are overriding or changing the implementation of this method. Now, over here, first we're going to add professor, followed by the first and last names. But we already implemented this piece of logic in our base class, so we don't want to repeat that here. This is where we use the super keyword once again. So let's remove this expression. We type super to reference the base class. So super dot full name. Okay? Now let's run our program one more time. Now we see Professor John Smith. So this is how we can override methods in TypeScript. Now, one more thing before we finish this lesson. In this case, we could still achieve the same result without using the override keyword. So if we run our program one more time, we still see Professor John Smith. There is a tiny problem though. The problem is that this method, this getter, is now disconnected from the one defined in the base class. And this can cause issues, as you will see in the next lesson. So as a best practice, we're going to enable a special compiler option that would remind us to use the override keyword. So let's go to tsconfig.json. In the type checking section, we have a compiler option called no implicit override. So we're not going to allow implicit overriding of methods. We have to be explicit about them. So now back to our teacher class, we have a compilation error saying this member must have an override modifier because it overrides a member in the base class person. So the compiler knows that we have a getter by the same name in the person class, and that's why it's complaining and saying, hey, you forgot to use the override keyword. So now we add that and the error goes away. Next, we're going to talk about a powerful technique built on top of method overriding called polymorphism. One of the core principles of object-oriented programming is polymorphism. Poly means many, morph means form. So polymorphism means many forms, and this refers to the situation where an object can take many different forms. Let's see this in action. So here's our teacher class. Right after, let's define a function for printing the name of some people. So print names takes a parameter called people of type person array. Now in this function, we're going to use a for loop to iterate over our person array. So for let person of people, we're just going to log person dot full name. Now let's call this function and give it an array of person objects. Now you know that every student is a person. The same is true for every teacher. So in this array, we can add student or teacher objects. So here we can add a student object and initialize it with 1 John Smith and a teacher object, Mosh Hamedani. Okay? Now let's run our program. So we see different output depending on the type of person. If we have a student, we see their name. If we have a teacher, we see their name prefixed with professor. Now, I'm not a professor and I don't ever want to be, so excuse me for that. But back to our code, what you see here is polymorphism in action. And this is extremely powerful, as you will see in a minute. Why is this called polymorphism? Well, in this for loop, let's hover our mouse over the person object. This object is of type person. But in each iteration of the for loop, this person object is taking a different form. In the first iteration, it takes the form of a student because the first element in this array is the student object. In the second iteration, our person object takes the form of a teacher object. And that is why the full name property or the full name getter gives us different outputs. So our person object is taking many different forms and is acting polymorphically. Now, why is this powerful? Well, because tomorrow we can create a new class like principal, which represents a school principal, and print its name without making a single change to this function. Let me show you what I mean. So here we're going to define a new class. called principal, which also extends the person class. Now here we're going to override the full name getter. And instead of professor, we're going to print principal. Okay? Now, because a principal is also a person, we can add a principal object in this array. Principal is going to be Mary Smith. Okay? Now, when we run our program, we see a different kind of output on this line. So what is happening here is that we have enhanced our program without a single change to this function. So we have implemented some new functionality just by writing new code. And this brings us to another principle of object-oriented programming called open-closed principle. This principle says our classes should be open to extension and closed for modification. So we should be able to extend them or inherit from them, but we should not modify them. Because if we modify or change a class, then potentially we might break something somewhere else and end up with a bug. If we properly test the class and know it's working, then we don't have to touch it. So we can enhance our application simply by adding new classes. So we write new code instead of changing existing code. This is the idea behind the open-close principle. Now, practically speaking, we cannot adhere to this principle 100% of the time. It's impossible and even costly. This is just a guiding principle. What I want you to take away from this lesson is that polymorphism allows us to follow this guideline. Again, there is way more to this. If you want to see more examples of polymorphism and open-close principle, you really need to look at my design patterns course. Now, one last thing I want to mention before we finish this lesson. In the previous lesson, I told you that we have to use the override keyword to tell the compiler that here we are overriding or changing the implementation of the full name getter. And this is how we achieve polymorphic behavior in this method. So the full name getter is defined in the person class, but we have changed its implementation in a couple of subclasses. Now, if we didn't use the override keyword here, this getter would be disconnected from the one defined in the base class. So someone could go and make a change there. Perhaps they could refactor that. They can change the name or restructure it, and this would break our polymorphic behavior. So that's it for polymorphism. Next, we're going to talk about private versus protected members. So far, you have learned about public and private members. But in TypeScript, we also have protected members. Let's talk about the differences. So here in the person class, you know that if we make the walk method private, we can access it anywhere within the class, but we cannot access it from the outside. So if we create a person object, we cannot call the walk method on that object. Now, protected members are exactly the same, so we can access them anywhere within the class, but not from the outside. The difference is that protected members are inherited, but private members are not. So the walk method is protected, and that means we can go to a child class like the student and access it. So if we type this.walk, it's right here. But if we make the walk method private, now this method is not inherited. It's only available in the person class. So here in the student, if we type this dot, we don't see the walk method. This is the difference between private and protected members. Now, protected members is something that you don't or you shouldn't use that often unless you know what you're doing, because they can create coupling in your applications. So just stick to public and private. I only talked about protected members here in case you see them in other people's code. So don't use them unless you really know what you're doing. Let's say we're building an application and we want to allow the user to draw something on a canvas. So here we're going to have classes like circle, rectangle, and so on. Now, all these classes should have some common properties like color, size, position, and so on. So let's define these common properties and methods in a shape class. So we define a new class called shape and give it a constructor with one parameter for now called color of type string. Now, here we should also have a method called render for rendering the shape. Now, here's the thing. At this point, we don't know how to render a shape because the rendering algorithm really depends on the type of the shape. So here we have to create another class like circle that extends the shape class. Now here we need a constructor. Let's add two parameters here. Every circle needs a radius, so public radius of type number. We also need color to pass to the base class. But note that here I didn't add the public keyword because we already defined this property in the base class. Okay? So in this constructor, we simply use the super keyword to call the constructor of the base class and pass the color. Good? Now, in the circle class, we simply type render and press enter. And VS Code automatically creates this function signature for us. So note that it automatically added the override keyword. So we don't have to remember to add it. Okay? Now, here we can simply log and say rendering a circle. So the actual algorithm for drawing a circle is implemented here. Now, similarly, we could have other classes like rectangle, triangle, and so on. And in all these classes, we implement the render method. Okay? Now, there is a problem in this implementation. Let's look at that problem. So with our current implementation, we can create a shape object with the red color and call its render method. Now, why is this a problem? Well, what does it mean to render a shape? This doesn't really make sense. We shouldn't be able to render a shape because shape is not a real thing like a circle. This is where we use abstract classes and methods. So if you want to stop us from being able to create an instance of the shape class, we mark this class as abstract. So on the top, before the class keyword, we type abstract. And with this, we're telling the TypeScript compiler that this class is abstract or simple or not ready. So another class like circle has to extend it. Okay? Now, with this, if we try to create an instance of a shape, we get a compilation error saying cannot create an instance of an abstract class. Okay? So an abstract class is like an uncooked meal. It's not ready. Another class has to extend it. Now, quite often in abstract classes, we have abstract methods. And these are methods that have no implementation. There's really no way for us to implement them, just like the render method here. So here we prefix the render method with abstract as well. Now we get a compilation error saying method render cannot have an implementation because it's marked abstract. So we have to remove the braces and terminate this line with a semicolon. Now we still have another error saying render which lacks return type annotation implicitly has an any return type. So here we need to annotate the return type, which should be void. Okay? So now we have an abstract class with an abstract method. Remember that abstract methods can only exist inside abstract classes. So if you remove the abstract keyword from here, we get a compilation error saying abstract methods can only appear within an abstract class. Okay? So this is all about abstract classes and methods. So you have learned a lot about classes. Now, in object-oriented programming, we have another building block called an interface. Now, as the name implies, we use interfaces to define the interface or shape of an object. For example, let's say we want to represent a calendar concept. Now, you know that we have different calendar implementations. For example, we have Google Calendar, we have iCal from Apple, we have Outlook Calendar, and so on. Now, all these calendars should have some common properties and methods. So we can define all these commonalities in a base class called calendar. So we define a class called calendar, give it a constructor with one parameter, name of type string. Now here we can have methods like add event, which should take an event object, but let's not worry about that event object and just add this method here. Similarly, we can have a method called remove event that takes an event object. Now, none of these methods can have implementation because the implementation really depends on the type of calendar. For example, how we record an event in a Google Calendar is certainly different from an Outlook calendar, right? So technically, we should declare all these methods and this class as abstract. So first, we make the class abstract. Then we make these methods abstract. Here we should remove the body and just add the return type annotation. So void. And one more time, abstract, void. Good. So now that we have an abstract class, we can create concrete implementations like Google Calendar, Outlook Calendar, and so on. But before we implement any new classes, let's compile our code and see what we get in JavaScript. So here in the terminal, let's run tsc. Good, and then go to index.js. So we have the calendar class with a constructor. Now, as you can see, we don't have the abstract keyword here because abstract has no representation in JavaScript. It's purely a TypeScript concept, okay? Now, this class is totally fine, but let's see what happens if we define the same concept using an interface. So, back over here, I told you that we use an interface to describe the interface or shape of an object. So using an interface, we can say all our calendars should have a name property as well as these two methods. So for comparison, I'm going to comment out these few lines and redefine the same concept using an interface. So we start with the interface keyword, then give our interface a name like calendar. Now, people coming from C# background, they like to prefix their interface names with a capital I. Some people don't like this convention. If you're one of them, don't use it. Don't waste your time arguing which convention is better. Should we prefix our interfaces with a capital I or not? There's really no point arguing about these things. So here's the calendar interface. Now here we should describe the shape of every calendar object. So in every calendar, we want to have a name property of type string, as well as these two methods, add event, which returns void, and remove event, which returns void as well. Now, immediately you can see that our new implementation is more concise, it's shorter, we don't have all these abstract keywords, but let's recompile our code and see what we get in JavaScript. So one more time, tsc, and then we go to index.js. Look, there's nothing here, because in JavaScript, we don't have interfaces. So this interface that we define over here is purely used by the TypeScript compiler for type checking. Now, here's a question. Shall we use an abstract class or an interface? Well, it depends. In this example, our calendar class is not providing any logic or any algorithm that subclasses can reuse. We just have a bunch of method declarations. So in this case, it's better to use an interface because our code will end up being more concise and shorter, both in TypeScript and in JavaScript, right? Now, in contrast, if we had some logic here, some algorithm, some method with a few lines of code, and we wanted to share that code amongst subclasses, then we couldn't use an interface because interfaces cannot have method implementations. So if we add braces here, we get an error. We only have method declarations. We only specify the signature of our methods, okay? So here we have an interface. Now, similar to classes, here we can use inheritance. So we can define another interface called Cloud Calendar that extends the calendar interface. So it's going to inherit all these members and add something extra. So here we can have a method like sync for synchronizing to the cloud. Okay. So now we have an interface. Then what? Well, at some point, we need concrete or real calendar implementations like Google Calendar. So we define a new class like Google Calendar. Now, instead of using the extends keyword, we use the implements keyword followed by an interface like calendar. Okay? Now here we have a compilation error saying class Google Calendar incorrectly implements interface calendar. Type Google Calendar is missing the following properties from type calendar: name, add event, and remove event. So the compiler is saying, hey, you haven't implemented this interface. Now let me show you a trick. Here we put the cursor on the class name. If you're on Mac, press Command and period. If you're on Windows, press Control and period. Now here we select Implement Interface Calendar. So VS Code automatically generates this code for us. Now here we have a compilation error for name because we haven't initialized it. Now unfortunately, at the time of recording this, we cannot convert this to a constructor parameter using a shortcut. So we have to manually create that constructor with one parameter, public name of type string. And now we remove this property, okay? So now we have a class that implements the calendar interface. Tomorrow we can create another class like Outlook Calendar that implements the same interface. Now both these classes will end up having the same shape. So using an interface, we can describe the shape of an object. That's it about interfaces for now. We'll talk about them again later in the course. So that brings us to the end of this section. In the next section, we're going to talk about generics. Welcome back to another section of the Ultimate TypeScript course. In this section, we're going to talk about creating generic and reusable types. We'll talk about generic classes, functions, interfaces, constraints, and a powerful technique for transforming types called type mapping. So let's jump in and get started. Before we talk about generics, let's talk about the problem they try to solve. So let's say we want to represent a key value pair. So we define a class called key value pair and give it a constructor with two parameters, key of type number and value of type string. And now we can create an object with these values, 1 and apple. Now, what if somewhere else in our application we wanted to use a string value for the key? With our current implementation, we cannot do this. We get a compilation error. So here we have two solutions. One solution is to use any here. Now we can pass any kind of object for the key. But as I told you before, we shouldn't use any as much as possible because with any we lose type safety. So if we type pair.key. Look, we don't see anything about the key. So we don't have type checking, we don't have IntelliSense, we don't see the properties and methods available in this key object. In contrast, if we had string here and typed pair.key. Now we can see all the properties and methods of the key, okay? So we don't want to use any. So let's revert this back to number. Now the other solution is to duplicate this class and call the second one string key value pair, where key is a string. And now we can perfectly use it right here, right? Now, the problem with this implementation is that it's redundant. What if somewhere else in our application, we want to use a person object as opposed to a string for the value? Then again, we will have to create yet another kind of key value pair class, and there is really no end to this. You have to constantly create new classes. So we need a generic, meaning a common and reusable solution. We'll talk about that next. All right, now let's see how we can use a generic class to solve this problem. So right after the class name, we type angle brackets, and in between the brackets, we type one or more generic type parameters. We can call this parameter T or anything we want, but T is a very common name because the idea comes from C++. In C++, we refer to these classes as template classes. So generic classes in TypeScript are the same as template classes in C++. And T is short for template, okay? So we defined a generic type parameter. Now we go in the constructor and change the type of key from number to T. And then when we create a key value pair object, once again, we type angle brackets. Look, we have a generic type parameter. So now we need to supply a value or an argument for this parameter. Now, if we type number and then open parentheses, look, we can see key is a number. In contrast, if we use string, now we can see key as a string. So let's supply a couple of values like 1 and a. Now, if we type pair.key. Look, we can see all the properties and methods of string objects. So we get type safety and IntelliSense, and we haven't duplicated our code. We have one generic and reusable class, but we're not done yet. In this example, we have only made the key generic, but we can also make the value generic as well. So we add a second generic type parameter. We can call that one U or anything we want. Another way to name these is T key and T value, or we can just use K and V. There's really no right or wrong. Different people like different naming conventions. So I'm going to go with K and V because they're pretty short and self-explanatory. So now we change the type of key to K and value to V. Now, when creating a key value pair object, we need to supply two generic type arguments. So we can use string or number or person or any kind of object for the value. This is the beauty of generics. Now, what if we don't supply the generic type arguments here? The compiler can infer the type of the key and the value. So because we have passed two strings here, the compiler knows that both key and value are string objects. So most of the time, we don't have to explicitly supply generic type arguments. The compiler can infer them for us. So this was generic classes. Next, we're going to talk about generic functions. Now, just like generic classes, we can also create generic functions or methods. So let's define a function called wrap in array. We give it a value of type number. And in this function, we simply wrap that value inside an array. Pretty simple. Now we call this function, give it a number, and get an array of numbers. Now with this implementation, we cannot pass a string value, and this is where we can use generics to make this function generic or reusable. So right after the function name, we type a generic type parameter like t, and then use that as the type of value. Now, if we pass a string, we get a string array. If we pass a number, we get a number array. Very useful. Now, this function could also be a method inside a class. So let's define a class called arrayUtils. Then we move this function inside this class. Now here we have to remove the function keyword because we use that only for defining standalone functions. So inside classes, we don't use this keyword, okay? So inside classes, we don't use the function keyword, okay? Now we can create a utils object, new arrayUtils, and here we call utils.wrapInArray. Or we could make this static, and you know that static methods belong to classes. So with this, we don't even have to create the utils object. We can directly say arrayUtils.wrapInArray. So this was generic functions. Next, we're going to talk about generic interfaces. In TypeScript, we can also make our interfaces generic. So let's imagine we have a website hosted at mywebsite.com, and here we have an endpoint for getting the list of users. Now, similarly, we can have another endpoint for getting the list of products. Now let's define an interface for representing the result of calling one of these API endpoints. So we call that result and give it a property called data. Now, we don't want the data to be a user or a product because this is not reusable. So this is where we use generics. So we add a generic type parameter here and then use that as the type of data. Now, if you want to expand on this, we also need an error here because sometimes when calling an API endpoint, we might get an error. So let's add an error property, and the type of this should be string or null because we may not necessarily get an error. Now, more accurately, the type of data should also be t or null, because if we have an error, then we don't have data, right? So now that we have a generic interface, let's see how we can use it. So we're going to define a function called fetch for calling an API endpoint. We give it a URL of type string, and we say this function should return a result of t. Now, because this function is returning a generic result, we should also add the generic type parameter right here, okay? Now, for simplicity, I'm just going to return an object with data and error set to null. We don't care about actually calling an API endpoint, okay? Now let's define two more interfaces. So one interface is going to be user. Let's say each user is going to have a username of type string. And we should also define an interface for our products. Let's say each product is going to have a title of type string. Now, let's see how we can use the fetch function along with these interfaces. So we call fetch. Now, if we don't type a generic type argument and simply open parentheses, look, we get result of unknown. So the TypeScript compiler cannot infer the generic type argument for us. We have to explicitly specify it. So we say we're going to fetch a user. And now, look, When we call this function, we get a result of user. This is how we read this expression, result of user. So let's pass some kind of URL. Now we get a result of user. So if we type result.data, we can see that data is a user object. So if we type result.data dot, we can see all properties of our user object. In contrast, if we fetch a product object, now data is going to be a product, so we see the title property. So this is how we can use generic interfaces. Next, we're going to talk about generic constraints. Sometimes we need to constrain generic type arguments. So let's define a simple generic function that takes a value of type t and simply returns that value. Now we can call this function and give it any kind of value. We can give it a number, a string, and so on. There are no limitations. But what if we want to constrain or limit the type of objects that we can pass here? Well, let's look at a few examples. So right after our generic type parameter, we type extends, and then we specify the type that can be assigned to t. So if we say number or string, we can only pass number or string values here. If we pass a boolean, we get a compilation error. That was one example. We can also constrain by the shape of an object. So instead of number or string, we can pass a shape object and say, here we need a property called name of type string. Now we can only pass objects that conform to this shape. So here we have to pass an object with a name property. Okay. We can also constrain by an interface. So we can define an interface called person that has a name property. And then we can say t extends person. That's another example. We can also constrain by class. So let's change this interface to class. And here we replace this with a constructor with one parameter. Now we can pass an instance of person or any classes that derive from person. So let's create another class called customer that extends person. Now, we don't want to add anything extra here. What I want to point out is that when calling echo, we can pass a new person object or a new customer object. So literally any object that is a person. That means an instance of person or any classes that directly or indirectly derives from person. Next, we're going to talk about extending generic classes. Let's talk about generic classes and inheritance. So let's say we're building an e-commerce application. So here we can have objects like products, categories, shopping carts, and so on. So let's start by defining an interface called product. And here we add two properties, name of type string and price of type number. Now, let's say we need a mechanism for storing these objects. So I'm going to define a class called store. Now, we want to be able to store different kinds of objects, products, orders, shopping carts, and so on. So here we need to add a generic type parameter and make this class generic. Now, in this class, we can have methods like add, remove, and so on. But first, we need an array for storing these objects. So let's add a property called objects of type t_array. Okay. Now, here we have a compilation error because we haven't initialized this property. But in this case, I don't want to create a constructor because it doesn't really make sense to create a new instance of this class and give it an empty array. This is just unnecessary. It's better to give this responsibility to this class itself. So I'm going to initialize this directly right here. Good. Now, let's add a new method like add, which takes an object of type t and returns void. Now, in this method, we say this.objects.push object. Okay. Now, in our current implementation, we can access the object's property from the outside, but we shouldn't be able to because we can accidentally wipe out this array. So we can create a store object, new store of product, and then we can accidentally set this.objects to an empty array. Okay, so we need to make this private so it's only accessible within the store class. So let's make this private and rename it to underline objects. Good. Now we cannot do something crazy like this. Okay, so we have a generic class. Now let's see how we can extend this class. I'm going to take you through 3 different scenarios. First, we're going to create a new class called compressible store. So in this store, whatever we add ends up getting compressed. So here we're going to extend the store class, which is generic. But look, we have a compilation error saying cannot find name t. So the compiler doesn't know what t represents here. So if we try to create a new instance of this class, new compressible store, look, currently we don't have a chance to pass a generic type argument like product. So what we need to do here is to add a generic type parameter here as well. Now the compiler knows that whatever we pass for t, like here, is going to be used as the argument for this generic class. Okay. Now in this class, let's add a simple method like compress. Okay. So now we have a compressible store. And in this store, we have 2 methods: add, that takes a product object, and compress, that we implemented in this new class. So in this scenario, we are passing on the generic type parameter. Okay. So the generic type parameter that we have in the base class is also going to be used in the child class. Okay. Now let's look at another scenario. So let's define another class called searchable store of type t that extends store of type t. Now in this class, we want to implement a method for finding objects. So we add find that takes a name parameter of type string and returns t or undefined in case we cannot find the given object. Now here we type return this dot object, but this property is not available because we made it private. So earlier I told you that private members are not inherited in child classes. So to fix this problem, we need to go on the top and make this property protected. Now back over here, we can access this dot underline objects. Now here we call the find method. Now the find method needs a predicate, which is an arrow function that takes an object and returns a boolean value. So we can take an object and then say object.name should equal to the name argument that we receive in this method. Now here we have a compilation error saying property name does not exist on type t. So the compiler doesn't know that this type t has a property by this name. Now here we can solve this problem by applying a constraint. So over here, we can say t extends an object with this shape, name string. So now we can use this generic class for finding any kind of object that has a name property. It doesn't have to be product. It could be anything. As long as we have a name property in that object, we can use this class to store that object and find it. Okay. So in the second scenario, we are restricting the generic type parameter. Now the last scenario. Let's say there are certain operations that can only be performed on products. So here we define a new class called product store that extends store of product. So in this scenario, we don't have a generic type parameter here because we're dealing with a very specific store. I don't want this to be generic. And for this reason, I've fixed or terminated the generic type parameter. So in this scenario, we are fixing or terminating the generic type parameter. Now, in this class, we can add a method like filter by category. So this operation is very specific to products. We don't want to use that in a user store or in a shopping cart store, right? So here we add a parameter called category of type string and return a product array. Then for simplicity, I'm just going to return an empty array. So here's what you need to take away. When extending a generic class, we have 3 options. We can fix the generic type parameter. We can restrict it, like in this case, we can apply a constraint, or we can simply pass it on to the child class. Let's talk about the key of operator in TypeScript. So we're continuing with the example from the previous lesson. We have the product interface and the store class. Now let's implement a find method in this class. So we add find and give it two parameters, property and value. With this, we should be able to find any object that has a property with this value, right? Now let's add the annotations. What is the type of property? It's string. What about the value? The value can be anything, but here we don't want to use any because that's a bad practice. Instead, we're going to use unknown. So we pass these values and we either get an instance of t or undefined if there is no object that satisfies this criteria. Now in this method, we're going to use the same technique we used in the previous lesson. So we're going to return this .objects.find. Here we pass a predicate, which is an arrow function. So we take an object and check to see if object of property equals value. Now here we have a compilation error. Don't worry about it. We're going to get back here in a minute. First, let's see how we can use this implementation. So we create a store object, new store of product. Now let's add an object here. So we pass a product with these values, name and price. Okay. Now we can call the find method and pass these values, name and a, or price and 1, right? Now there's a hidden problem here. With this implementation, we can call the find method and pass a non-existing property. And when we run our program is going to crash because there is no product by this name in the product interface, right? So this is where we use the key of operator to solve this problem. Now, back to the arrow. What is the compiler saying? The compiler is saying no index signature with a parameter of type string was found on type unknown. So because we're using the square bracket syntax, the compiler thinks we're using an index signature property. So earlier I told you that we use index signatures for dynamically adding properties to an object. But in this case, we're not dealing with dynamic properties. We're dealing with actual properties of an object. So let's look at the error one more time. The error is saying no index signature with a parameter of type string was found on type unknown. So to solve this problem, we should tell the compiler, no, we are not using an index signature. We are working with actual properties of type t. And to do that, we just change the type of property from string to key of or property of t. So the property that we pass here can only be one of the keys or properties of type t. So if t is product, then key of t is going to return name or price. So the key of operator returns a union of properties of the given type. And that is why we can only pass either name or price when calling this method. So if we pass a non-existent property, we're going to get a compile time error. So using the key of operator, we can catch this kind of issue at compile time. Sometimes we need to base a type on another type. This is called type mapping. For example, here we have the product interface with two properties. Now, what if somewhere else in our application, we need a product with read-only properties? Well, one option is to duplicate this interface, call the second one read-only product, and make each property read-only. But this is very repetitive. And also, every time we add a new property in the product interface, we have to remember to add that property in the second interface as well. Not a good solution. Let me show you a better way. This is where we use type mapping. So we're going to create a new type based on an existing type. But in this new type, we want to add all these properties dynamically and make them read-only. So we start with the type keyword because here we have to create a type alias. So we cannot use an interface. We call this read-only product. Now here we're going to use two tools you're familiar with. One of them is index signature. The other is the key of operator. So instead of hard coding these property names here, we're going to use the index signature syntax to dynamically add properties. And using the key of operator, we're going to dynamically get the properties of the product type. So I'm going to write an expression like this. we add square brackets, then we type property in key of product. So using the key of operator, we're getting all the keys or properties of the product. Now using the in operator, we're iterating over these keys, and property in each iteration is going to hold one of these property names. So in the first iteration, it's going to be name. In the second iteration, it's going to be price. So this is kind of like a for loop, okay? So we get these properties. Now, what about the type of these properties? We want to use the same type we have used in the product interface, right? So here we type product of property. So if property is name, product of property will return string. If property is price, product of property will return number, okay? Now here we can rename property to P if you prefer shorter code, or we can change it to K so it's consistent with key of. So we're getting all the keys of a product as well as their type, okay? Now we can make all of them read-only in one go. This is what we call type mapping. So now if we create a product of this type, all these properties are going to be read-only. So if we create a product of type read-only product, let's set its properties, name and price. Now we cannot change any of these properties. So if we set name to some other value, we get a compilation error, okay? Now let's take this to the next level. Why do we limit ourselves to product? What if we need another type of read-only object, like read-only customer? So here we can use a generic type. So we're going to remove product and add a generic type parameter, and then replace all product instances with T. So T and T. As simple as that. Now we can create a read-only product or a read-only customer or any kind of object. Very useful. Now using the same technique, we can create a product type with optional properties. So all properties are going to be optional. So once again, we'll start with the type keyword. We call this optional of T. And here, once again, we get all the keys of T. So K in key of T. Now to make each property optional, we append a question mark at the end. And for the type, once again, we use T of K. Similarly, we can create another type and make each property nullable. So let's call this nullable. And over here, we're going to change the type to T of K or null. So the possibilities are endless. Now, because these types are pretty useful, they're actually built into TypeScript. So if you Google TypeScript utility types, you will find this page on typescriptlang.org. On this page, you can see all the utility types that are available to you. So partial is like our optional. With this, we can make all properties optional. We also have required, where each property is required. We also have read-only and so on. Now, there are quite a few types here, and there is really no point for me to go over all of them because this page is perfectly documented and you can see various examples. So spend a few minutes and go over this page to see what types are available to you. And that brings us to the end of this section. In the next section, we're going to talk about decorators. Welcome back to another section of the Ultimate TypeScript course. In this section, we're going to talk about decorators, which allow us to change and enhance our classes. So we'll start by a quick introduction to decorators and how they work. Then we'll look at creating various types of decorators, such as class decorators, method decorators, property decorators, and so on. So let's jump in and get started. So what are decorators? Well, decorators are attributes that we apply to our classes and their members, and with this we can change how they behave. They're frequently used in Angular and Vue applications. For example, you might have a class called profile component. Now, by applying the component decorator, we can convert this class to a component for a web application. Now here we have a compilation error because TypeScript doesn't have this component or any built-in decorators, so we have to create our own. And that's why these frameworks like Angular and Vue, they come with a bunch of built-in decorators like component, pipe, and so on. Now, under the hood, this decorator is just a function that gets called by the JavaScript runtime. So the JavaScript runtime or the the JavaScript engine that executes our code is going to call that function and pass our class to it. Now, in that function, we have a chance to modify this class. So we can add new properties, we can add new methods, or we can change the implementation of existing methods. I'm going to show you various examples in this section. Now, before we can create any decorators, first we have to enable a special compiler option because decorators are an experimental feature and their standards and implementation might change in the future. So let's go to our tsconfig file. Here in the language and environment section, we have a setting called experimental decorators. Let's turn that on. Good. In the next lesson, I'm going to show you how to create your first decorator. All right, let's see how we can create a decorator that we can apply to our classes. So I told you that a decorator is just a function that gets called by the JavaScript runtime. So let's define a function called component. And once again, note that here we are using Pascal naming convention. So the first letter of every word should be uppercase. Now, depending on where we're going to apply this decorator, the number and type of parameters varies. So if we're going to apply this on a class, here we should have a single parameter that represents our constructor function. We can call that anything, but it's better to call it constructor. What matters is the type. If the type is a function, the runtime assumes that we're going to apply this on a class. And this represents our constructor function, okay? Now in this function, we have a chance to modify or enhance our class. So we can add new properties and methods, we can change existing methods, we can even delete properties and methods. There are no limitations. So first let's log something on the console and say component decorator called. Now here we can take our constructor and go to its prototype. Now if you're not familiar with prototypes, I've covered them in detail in the second part of my ultimate JavaScript series. But practically speaking, every object in JavaScript has a prototype from which it inherits various properties and methods. So we can go to this prototype and add new properties and methods. Then all instances of profile component or any classes that has the component decorator will inherit those new properties and methods. Okay, so let's add a new property like unique ID and we set it to date.now. We can also add a method called insert in DOM. So let's say every component should have a method for inserting it in the DOM or document object model. So when we add a component in the DOM, then the browser is going to show that component to the user, okay? So here we define a function and simply log inserting the component in the DOM, okay? So now every instance of profile component is going to have these new members. Now we could also solve this problem using inheritance. So instead of defining a decorator, we could create a base class like component. Here we could define insert in DOM. And then we could have our profile component extend the base component class. This is another way to solve the same problem. But decorators are just another tool in our toolbox, okay? So let's revert this back and bring back our decorator, okay? Now let's run our program and see what we get. So let's compile and run index.js. All right, look, we got this message even though we didn't create any instances of the profile component. So whether we have 0 or 10 instances, this decorator is called once, and this is our chance to enhance or modify our classes. Now let's look at the generated JavaScript code. So in our project in the dist folder, let's look at index.js. So on the top, we have a function that is automatically generated for us. It's the decorate function, and this is where all the magic happens. So right after that, we have our component decorator. Next, we have our profile component. And finally, we have a call to the decorate function with our decorator and class as arguments. So this is how the runtime calls our component decorator to enhance our profile component. Sometimes we need to pass arguments to our decorators. So let's see how we can create parameterized decorators. First, I'm going to temporarily comment out our decorator function and redefine it. So function, component. Now in this example, we're passing a number. So let's add a parameter called value of type number. Now in this function, all we have to do is return a decorator function. So let's move this code right here, remove the comment and add the return keyword. Now this function doesn't need a name, so let's remove component. We can also improve this code by using the arrow function syntax. It makes the code slightly more readable. So we remove the function keyword and add a fat arrow right here. That's all we have to do. So now we have what we call a decorator factory. So this function is acting as a factory for creating a decorator. Okay. So we take a value. Now we can use it anywhere in this function. So we can add a new property here, constructor.prototype.options. We set it to this value. But let's take this to the next level and make it more real world, like what you see in frameworks like Angular. So instead of passing a number, let's pass an object with special properties. So first we define a type called component options. Now here we can have a property like selector, which is going to be a string. Now we rename value to options and change number to component options. And finally, when using our decorator, we pass an object like this. Selector is going to be the ID of an element in the DOM. So we can say my profile. Now, if you have never done front-end development, don't worry about this fancy syntax. All I want you to pay attention to here is that we're passing an object as an argument to this decorator. We can also apply multiple decorators to a class or its members. So let's define another decorator called pipe that takes a constructor of type function. Now here we're going to log and say pipe decorator called. Then we're going to take constructor.prototype and add a new property to it called pipe. Pretty simple. Now let's apply this after the component decorator. So now let's run our program and see how these decorators are called. So compile and run. All right, look, our decorators are applied in the reverse order. So first, the pipe decorator is called, and then the component decorator. The idea behind this comes from the math. So in math, if we have an expression like f of g of x, you know that first g of x is evaluated, and then the result is passed to f, okay? So in this case, because each decorator is a function, first the pipe decorator is going to get called with our profile component. So it's going to enhance our component, and then the result is going to get passed to the component decorator. Next, we're going to talk about method decorators. All right, let's see how we can enhance our methods using decorators. So let's define a person class with the same method that takes a message of type string. And here we log person says the message. Good. Now we're going to implement a decorator and apply it on this method. So just like before, we create a function. Now to apply this on a method, here we need 3 parameters. So instead of a constructor function, we need 3 different types of parameters. The first parameter is the object that owns the target method. So target of type any. Now, I know that I told you that we shouldn't use the any type as much as possible, but in this case, any is the type that the TypeScript compiler expects from us, okay? The second parameter is the name of the target method. So method name of type string. And the third parameter is the descriptor object for the target method. So descriptor of type property descriptor. Now, if you're not familiar with property descriptors, I covered them in detail in the second part of my ultimate JavaScript series. But very briefly, every property in an object has a descriptor object that describes that property, okay? And by the way, you don't have to memorize any of these parameters. If you simply Google TypeScript decorators on this page on typescriptlang.org, you can see various examples. So on the right, we have class decorators, method decorators, and so on. So let's look at method decorators. Here we have an example. Look, we have a function with 3 parameters: target of type any, property key of type string, and descriptor of type property descriptor. So once again, the name of these parameters doesn't matter. What matters is their number and type. Okay? So back to this function. Now here we can do some really cool things. For example, we can completely replace this method with an entirely new method. So look, this descriptor object has a property called value that references the target method. So we can set this to a new function to replace the original function or method. So a function with no parameters, and here we simply log new implementation. So now this function is going to replace the same function, or more accurately, the same method in the person class. Now, this is the nuclear option. Most of the time, we don't want to do this. We want to enhance an existing method. So we want to do something before or after that method. So let's change the message to before. We're going to do something first. Also, we're going to do something after. And in the middle, we're going to call the original method. But before we can do that, first we need to get a reference to the original method. So let's declare a variable called original and set it to descriptor.value. Now, in this case, it's better to use the const keyword because we don't want to accidentally reset this variable to something else. Okay? So we have the original function. Now, how can we call it? Very easy. We type original dot. Now look, we don't get IntelliSense here because the type of value property is any. So here we need to use type assertion and tell the TypeScript compiler that this is a function. So right here, we type as function. Okay? Now if we type original dot, we can see all the properties and methods of functions in JavaScript. So here we have a method for calling a function. So we call this, and here we need to pass 2 arguments. The first one is the this keyword. So this, and the second one is the argument or arguments we want to pass to the target function. So look, our say method has 1 parameter of type string. So over here, we can hard code a value as an argument. We can say blue sky. So now, if we create a person object and call person.say hello, this value that we pass here is going to get ignored because it's going to be replaced by this hard-coded value, because this is the new implementation of the same method. So in this new implementation, we don't have a parameter like message. We have hard-coded a value that we're going to pass to the original method. Okay? Now, what if we want to use the actual argument that we pass over here? Well, while redefining the same method, we can add the message parameter, message of type string, and then we pass it right here. Okay? So let's run our program and see what we get. But before we do so, first we have to turn off a special compiler option, because here we have a couple of unused parameters and TypeScript compiler is going to complain about them. So let's go to tsconfig.json. Here in the type checking section, we have a compiler option called no unused parameters. We turned this on earlier in the course, but now we have to temporarily turn it off. Okay? Now here in the terminal, let's compile and run our program. So we see before, then we see person says hello, and after. Great. So using this decorator, we have enhanced our method. However, there is a tiny problem here. With this implementation, we can only apply this decorator on functions or methods with this signature, methods that have 1 parameter of type string. Not very flexible. So what can we do here? Well, to make this more flexible so we can apply this decorator on any type of method, first we need to replace string with any. Then we rename message to something more generic, like args. And using the rest operator, we allow this function to take varying number of parameters. So now we can apply this on a function with 0, 1, 2, or more parameters. Okay? And also, while calling the original function, we're going to use the spread operator. So we spread all these arguments and pass them one by one to the original function. Okay? So this is how we can enhance a method using a decorator. Now, one last thing before we finish this lesson. Note that over here, we are using a function expression and not an arrow function. If we use an arrow function, we get a compilation error because arrow functions don't define their own this keyword. So we cannot use them as methods in a class. So when redefining methods, we should always use a function expression. Now let's see how we can create a decorator to apply on accessors, meaning getters and setters. So let's define a person class with a constructor with two parameters, first name and last name. Now in this class, we're going to define a getter called full name. And here we're going to return a template string. Inside the string, we're going to add this.firstName and this.last name. Now let me show you a tip. When accessing properties and methods of an object, you don't have to type their full name like last name. You can use abbreviations. So ln is enough to bring up the last name property, okay? So we have a getter. Now we're going to define a decorator called capitalize for capitalizing the return value of this getter. So let's define a function called capitalize. Now, accessor decorators are very similar to method decorators because this accessor, this getter, under the hood is just a method, right? So what parameters do we need here? 3 parameters, target of type any, method name of type string, and descriptor of type property descriptor. Now, in this function, just like before, first we need to get a reference to the original method, to the original getter. So constant original. Now previously we used descriptor.value, but this doesn't work for getters and setters. It only works for regular methods. So here we have to use the get property. Now we need to redefine this getter. So descriptor.get equals, here we use a function expression. Now getters cannot have any arguments, so here we're not going to have args, okay? We just have a function. In this function, first we call the original getter. So original.call, and here we pass this. Now, note that VS Code automatically added this question mark here. This is called optional chaining. The reason we see this is because original can be undefined. Look at the type of original. It's either a function with no arguments that returns any or undefined. That's why we have optional chaining here. So this code is the shorthand for code like this. If original is not null and it's not undefined, then original.call this. So this line is just a shorthand for these 2 lines, okay? Delete. Now in this case, we know that original is not going to be undefined because we're going to apply this decorator on a getter. So original will always have a value. In this case, instead of a question mark, we could use an exclamation mark. And with this, we're telling the compiler, hey, I know this is not going to be null or undefined, so trust me, okay? Either way works. So we call the original getter, get the result, and store it here. Now, once again, I'm using the constant keyword here because I don't want to accidentally change the result. Now, look at the type of result. It's any. So here we should check to see if result is a string object, then we're going to return string the 2 uppercase. So if type of result equals string, then we're going to return result the 2 uppercase. Otherwise, we're going to return the result itself. Now we can simplify this code and use a conditional expression. So return, if this expression is true, we're going to return result the 2 uppercase. Otherwise, we're going to return the result itself. So now we have this decorator. Let's see everything in action. So let's create a person object with my first and last name in lowercase. Then we're going to log person.fullName. Now let's compile and run our program. There you go. So you see my name in uppercase. Now, what if instead of a string, we return a number here? Let's make sure our code still works. So one more time, we get 0, beautiful. Now, what if we return null here? Let's make sure our code still works. So one more time. Okay, we see null. Beautiful. Next, we're going to talk about property decorators. All right, now let's define a decorator for enhancing a property. So let's define a user class and give it a password property of type string and a constructor for initializing this property. Now, in this case, we cannot use the public modifier here and avoid typing this property because we're going to apply our new decorator on this property itself. So let's bring this back and remove the public keyword. Good. Now, our new decorator is going to be called min length. And with this, we can ensure that our passwords are at least, let's say, 4 characters long. So let's define a function called min length. Now here we need a parameterized decorator. So let's give it a parameter called length of type number. Now here we're going to return the actual decorator function. Now, property decorators are very similar to method decorators. So here we're going to return a function with 2 parameters, target of type any and property name of type string. So very similar to method decorators, but here we don't have a property descriptor, okay? Instead, we're going to define a property descriptor for the target property. So we declare a variable of type property descriptor. Now, it's actually better to use the const keyword here because we don't want to accidentally reassign this, okay? Now in this object, if we press Control and space, we can see all properties and methods of descriptor objects. So here we have a bunch of optional properties because all of them have a question mark at the end. Now out of these, in this lesson, we're going to work with get and set. So here we can define a setter for the target property, and in that setter, we can perform data validation. So if the new value is less than, let's say, 4 characters long, we can throw an error. So let's define a setter that takes the new value as a string. And here we can check to see if new value, the length, is less than the length that we have specified up here, then we're going to throw an error. So throw new error. Property should be at least 4 characters long. Now, we don't want to hard code these values like 4. We want to render them dynamically. So instead of using single quotes, we're going to use backticks to define a template string. Now, in a template string, we can have placeholders for rendering values dynamically. So instead of 4, we're going to add $ braces, and this is going to be the placeholder for the length parameter. Now, similarly, we're going to render the property name dynamically. So one more time, $ braces, property name. Good. So this is our data validation logic. If the value is valid, then we're going to store it somewhere. But where? Well, in this decorator function, we can declare a variable called value of type string. And if the new value is valid, we can set value to new value. Now we also need a getter for returning the value of this variable. So in this descriptor, let's define a getter. And here we simply return the value. Okay? So now that we have a descriptor object, the last step is to assign it to the target property. So right after, here we call object that define property. And here we're going to pass 3 values: the target object, property name, and the new descriptor object. Okay? Now let's see this in action. So let's create a new user. New user. Now if we pass a password that is at least 4 characters long, everything is going to work. So let's log user.password. So let's compile and run our program. There you go. Everything is working well. But if you pass a password that is less than 4 characters long, we're going to get an error. Now, similarly, if we pass a valid password initially, but then we reset it to something invalid, then once again, we're going to get an error. So every time we try to set the password, our decorator gets called and validates the new value. So with property decorators, we can enhance existing properties. The last decorator type we're going to talk about is parameter decorator. Quite frankly, it's not something you use that often, but if you're designing a framework for other people to use, then you might want to know how these parameter decorators work. So let's start by defining a vehicle class with a move method that takes the speed as a number. Now we're going to define a parameter decorator for watching this parameter. So let's define a function called watch with 3 parameters: target of type any, method name of type string, and parameter index of type number. The parameter names are quite self-explanatory, so there is no need for me to explain them. Now, at this point, there is really not much we can do with this parameter. Quite often, we store some metadata about these parameters, so later our framework can do something about them. Let me show you what I mean. So let's define a new type called watched parameter. There are 2 pieces of information we need to know about these watched parameters: the method name and parameter index. Now, method name is going to be a string and parameter index is going to be a number. Okay? Now that we have this new type, let's define an array of watched parameters. So let, or const is better, watched parameters is of type watched parameter array. And here we initialize this to an empty array. Now, in this decorator function, all we can do right now is store an object in this array. So watched parameters.push. Here we add an object with 2 properties: method name and parameter index. So we're collecting some metadata, and our framework later on can use this metadata to do something. Perhaps at some point we're going to create objects and we want to know what parameters we should watch. So let's not worry about all these complexities and just log the list of watched parameters on the console. All right, take a look. So now we know that in the move method, we have to watch the first parameter. Welcome back to another section of the Ultimate TypeScript course. In this section, I'm going to show you how to use modules to organize your code. We'll start by discussing how to create and use modules. Then we'll talk about module formats and how to configure the TypeScript compiler to generate code for different formats. And then we'll explore additional techniques such as default exports, wildcard imports, and re-exporting for writing cleaner and more concise code. So let's jump in and get started. So far, we have written all the code in just one file, but that's not how we build real applications, because as our code grows, maintaining these large files gets harder and harder. So we should split our code into different files or modules, each serving a purpose, just like how we organize our kitchenware in different cabinets and containers. So here we have 2 classes, circle and square. Now I'm going to move this to a new file or a new module called shapes. So back to our project. Here in the source folder, let's add a new file called shapes.ts. Now let's move all this code right here. Okay. Now these classes are currently only accessible within the shapes module, so we cannot use them anywhere else unless we export them. So let's export the circle class so we can use it in the index module. Now, back in the index module, on the top we type import braces from, and here we type the name of the target module as a relative path. So we type a period and a / to reference the current folder, and then we type the name of the target module, in this case shapes. Now, note that here we don't type .ts or the extension, just the file name, okay? Now, if you want to go one level up, instead of 1 period, we use 2 periods, okay? So here we have the shapes module. Now back to the braces. Now if we press Control and space here, we can see all the exported objects from this module, in this case, circle. Now, while importing this, we can optionally rename it to something else like myCircle if we have another class or another interface or another type in this module with the same name. This way we can prevent name clashes. And currently we don't have this scenario, so this is unnecessary, okay? Now let's go back to the shapes module and also export the square class. So we can import it right here. So we type a comma followed by the new type, okay? So now that we have imported these classes, we can use them just like before. So we can create a circle object with a radius of 1 and then log its radius. Now, VS Code is complaining that we have imported the square class, but we have never used it. So we can put the cursor here. If you're on Mac, press Command and period. If you're on Windows, press Control and period. And here we select remove unused declaration for square. With this, we can clean up our code. Also, it's nicer to add spaces inside the braces. That makes our code slightly more readable, okay? Now, let me show you a shortcut. We don't always have to manually import objects on the top. In a lot of cases, VS Code can help us. So I'm going to delete everything here and just create a circle object. Now note that the moment I type circle and press enter, VS Code automatically added the import statement for us. Beautiful. Now, what if we were not typing this? What if we copied this code from somewhere else? So let me remove this and just create a circle. Imagine we copied this from somewhere. Well, you can see that here we have a compilation error, right? So once again, we can press Command and period or Control and period. And here we select add import from shapes. That's a very useful shortcut. Now, let me show you one more shortcut before we finish this lesson. So let's define an interface called product with a name property of type string. Now, if we want to move this to a new file, we can put the cursor on the interface name. Once again, we press Command and period or Control and period. And here we select move to a new file. Now, in our project, we have a file called product.ts. Now, note that in this case, VS Code is using the Pascal convention for naming this file because we have defined a type with this name in this file. Which convention you use really depends on you. There is no right or wrong. Different teams like different conventions. So that was the basics of creating and using modules. Next, we're going to talk about module formats. All right, now let's talk about module formats. So in the old days, JavaScript didn't have a module system. So we used various techniques and formats to modularize our applications. If you have been coding in JavaScript for 10 years or longer, you've probably heard of module formats like AMD, UMD, CommonJS, and so on. Now, starting with ES 2015 or ES6, modules have become natively supported in JavaScript. So this syntax we have for exporting or importing objects, this is part of the ES6 modules. Now, these days, this format is widely supported in pretty much all browsers and JavaScript runtimes out there, so we don't really need the other formats anymore. But let's spend a couple of minutes and see these module formats in action so they are not foreign to you. So let's go to our tsconfig file. Here in the module section, we have a compiler option called module that is set to CommonJS by default. This is the module format that initially came with Node. So now let's compile our code and see the generated JavaScript code. So here in the terminal, let's run tsc. Good. Now let's look at shapes.js in the dist folder. So look, our code looks different. So our classes don't have the export keyword in front of them. Instead, we have a statement like this: exports.circle equals circle. What is happening here is that exports is an object that contains everything we're going to export from this module. Now on this line, we're adding a property on this object called circle, and we're setting it to the circle class we defined over here. So this is the CommonJS format for modularizing applications. Now in index.js, look, we no longer have an import statement. Instead, we have a call to the require function. So we are requiring this module to load it, and then we are referencing shapes.circle to create a circle object. So this is the CommonJS format. Now, the great thing is that you don't have to learn this format if you're using TypeScript. So you can continue using import and export statements, and the TypeScript compiler will translate your modules into the CommonJS format if that's what you need in the generated JavaScript code. Now let's see what happens if we change our module format. So back to tsconfig. Let's remove common.js and press Ctrl and space to see all the available options. So we have AMD, common.js, ES 2015, ES 2020, ES 2022, and so on. Now, honestly, I'm not sure about the difference between ES 2020 and ES 2022. Most of the time, we use ES 2015 because that's widely supported. So let's set that. Now let's recompile our code and have a look at shapes.js one more time. Take a look. This is the syntax we used for exporting these classes, right? Now let's look at index.js. And over here, we have the import statement. So depending on the module format we set in our tsconfig file, the generated JavaScript code is going to be different. Sometimes we just want to export a single thing from a module. In those cases, it's better to use a default export. Let me show you what I mean. So here in the source folder, let's add a new file called storage.ts. In this module, we're going to define a class called store for permanently storing some objects. So here we can have methods like add, find, delete, and so on. Let's not worry about those details. Now in the same module, we can have other classes like compressor and encryptor for compressing and encrypting objects while storing them in the storage. Now, in this case, I don't want to export these classes because these are part of the implementation detail of this module. So other modules should not know about their existence. All they need to know is the store class. So they just create a new store and add an object to it. Everything else is implementation detail. Let me give you a metaphor. Think of a remote control. A remote control has a bunch of buttons on the outside and a bunch of other stuff on the inside. You're not supposed to touch anything on the inside. What is inside is considered the implementation detail and it might change in the future. What matters is what is on the outside. So in this module, if we export these classes, other modules might potentially use them and become dependent on them. Then in the future, if we decide to change these classes, if we decide to remove them or restructure them, other modules that are using these classes might potentially break. So we should reduce the surface area of our modules. We want to make our modules like a remote control with very few buttons. This way we can reduce the coupling or dependency between our modules, okay? So here we can export the store class and then go to our index module and import it just like how you learned earlier. Now this is good, but if you're exporting only a single thing from a module, there is a better way. So back to the storage module. Here we type default to indicate that this is the default object exported from this module. Now, while importing it, we no longer need the braces. So that makes our code slightly cleaner. Now, default exports can also coexist with named exports. For example, back to our storage module, let's define an enum called format. And here we can have members like raw and compressed. Let's imagine that other modules need to know about the format enum. So we're going to export it just like before. Now, while importing these objects here in the index module, first we import the default object, and then we add braces, and here we import the named exports like the format enum, okay? So this is all about default exports. Sometimes we need quite a few objects from a module, so importing them one by one can be a bit of a hassle. For example, let's import circle and square from the shapes module. Now here we're importing only 2 classes, but what if we were importing 10 classes or more? We would end up with a really long import statement, right? In those cases, we can use a wildcard import to simplify our code. So we remove the braces and type import everything as shapes. So now we're importing all the exported objects from this module and putting them inside a bucket or a container called shapes. So if we type shapes dot, we can see all the exported types. So here we can create a circle like this. This is what we call a wildcard import. All right, let's talk about re-exporting. With re-exporting, we can have a single module combine the exports of different modules. Let me show you. So here in the source folder, let's add a new folder called shapes. Then we move the shapes module in this folder. Now look at the shapes module. Currently we have defined both these classes in the same module, and there is nothing particularly wrong with this, but as these classes get larger and larger, this module becomes harder to maintain. In that case, it's better to split this module into a few different modules. So now let's put the cursor on each class and move it to a new file. Good, and one more time. Okay, so now in the shapes folder, we have two extra files, circle and square, and the shapes module is empty. Now let's go to the index module and bring these two classes. So first we import circle and then square. Now there's nothing significantly wrong here, but what if we had 10 types of shapes that we had to import on the top? We would end up with 10 import statements, right? This is where we can use re-exporting to combine all these modules into a single module, and then we'll import only that single module here. Let me show you. So back to the shapes folder. First, we rename shapes.ts to index.ts. So in this module, we're going to combine the exports from these other modules. So this is where we import the circle class and the square, and then we export them at the end. So export braces, circle, and square. Okay. Now with this new structure in index.ts, we don't have to import circle and square separately from two separate modules. Instead, we can import circle and square from shapes/index module. That is better, right? But we can take this to the next level. We don't even have to type the index module. So we can simply import them from the shapes folder, or sometimes we refer to this as a package. So shapes package. Now here we have a compilation error saying, cannot find module shapes. Did you mean to set the module resolution option to node or to add an alias to the paths option? To fix this problem, we have to go to our tsconfig file. Here in the module section, the default module resolution setting is classic, which is for backward compatibility. So it's a good practice to uncomment this line and set the module resolution to node as opposed to classic. With this, we no longer get that compilation error and our code is cleaner. Now, there's one more thing I need to show you here. Back to this index module, we have a shorthand syntax for importing and exporting these classes in one go. So we remove the last line and change import to export. So now we import and export these classes in one go. This is what we call re-exporting. Welcome back to another section of the Ultimate TypeScript course. In this section, you will learn how to run TypeScript and JavaScript code side by side. So first, I will show you how to include JavaScript code in your TypeScript projects. Then we'll talk about type checking JavaScript code using JSDoc and declaration or type definition files. And finally, we'll talk about using the declaration files from the definitely typed repository. So let's jump in and get started. So far, we've been coding purely in TypeScript, but that's not always possible because you might have a JavaScript project and decide to introduce TypeScript later on, or you just want to work with some existing JavaScript code. So for this demo, let's add a JavaScript file in the source folder. We're going to call that tax.js, and here we're going to export a function called calculateTax that takes an income, and here we return income times 0.3. So we have a regular JavaScript file, and that means in this file, we cannot use any TypeScript features. So we cannot annotate this parameter with number, okay? So we have a regular JavaScript file. Now let's import this function into the index module. So we import calculateTax from the tax module, okay? Now we get a compilation error because by default, JavaScript code is not included in the compilation process. So the TypeScript compiler cannot see our tax module. To solve this problem, we have to go to our tsconfig file. Here in the section called JavaScript support, we have to turn on this compiler option called allow.js. Now, back to the index module, we still see the error. Don't worry about it. This is just a temporary issue in VS Code. So here we can call calculate tags, pass some value, get the tags, and then log it on the console. Now let's compile and run our program. We get a compilation error saying cannot use import statement outside a module. The reason we see this is because in the last section, we changed our module format to ES 2015, and that is used by browsers. We can use that in Node applications as well, but that requires a little bit more work. So to solve this problem, we have to go back to tsconfig.json. On the top, we're going to change the module format to common.js. Now let's compile and run our program one more time. Okay, it's working beautiful. Next, I'm going to show you how to enable type checking in JavaScript code. When using JavaScript code, by default, we don't get any type checking. So that means we can call this function without supplying an argument, and we'll not know about this issue until runtime. So we have to compile and run our program to see some weird result. Now, to solve this issue, we go back to tsconfig.json. Here in the JavaScript support section, we have another compiler option called check.js. If we turn this on, we get some basic type checking. It's not as comprehensive as what we get in TypeScript files, but it's better than nothing. Now let's recompile our code and see what we get. Look, in tags.js on line 1, we have a compilation error saying parameter income implicitly has an anytype. So we are seeing this because earlier in the course, we turned on a compiler option for catching this kind of errors. So we shouldn't use the anytype unless we explicitly type it out, right? So now we have two options here. One option is to describe type information to the TypeScript compiler. We'll talk about that in the next lesson. But let's imagine that we're getting a ton of errors in this file and we want to temporarily tell the TypeScript compiler to stay silent. So let's go to tags.js. On the top, we add a special comment. Here we type an @ followed by ts-no check. So we add this once on top of a file that we don't want the TypeScript compiler to check. Now let's recompile and run our program one more time. All right, we don't get a compilation error, but we still see this weird result. Why is that? So back to the index module, you might be wondering why the TypeScript compiler is not complaining even though we are not supplying any arguments to this function. Here's the reason. If we don't supply an argument, undefined will be passed to this function. And because the type of income parameter is any, it can receive any type of arguments. So it can receive undefined. That is why we don't get a compilation error here. In the next lesson, I'm going to show you how to describe type information to the TypeScript compiler, so we'll be forced to pass a valid argument here. So one way to describe type information for our JavaScript code is using JSDoc, which is a special type of comment we can add to our code. Let me show you. So first we remove this line, then we type a / followed by 2 asterisks. Now look, VS Code detected this line as a JSDoc comment. So let's press enter to generate the comment. Good. So you can see we have one parameter called income. And here in braces, you can see the type of this parameter. Now at this point, VS Code doesn't know the type of this parameter. That's why we have an asterisk here. So here we need to jump in and explicitly set the type of this parameter to number. Now similarly on the second line, we can specify the type of the return value. So once again, we type braces with number. Now let's recompile our code and see what happens. All right, this time we get a compilation error in index.ts on this line. The error is saying we expected 1 argument, but we got 0. So let's go to index.ts and supply an argument right here. Good. Now, in the previous videos, I had a compilation error on this line saying there is no type definition file for this module. If you get the same error, just restart VS Code, okay? Now let's recompile our code one more time. All right, no more compilation errors, great. So using JSDoc, we can provide type information to the TypeScript compiler, but we can also explain our code. For example, on the first line, we can provide a description for this function. We can say calculate income tax. Then similarly, we can explain each parameter. For example, here we can say net salary after expenses. Now, back to index.ts. If you hover over this function, we can see the descriptions we provided. That's very useful. So this is JSDoc, but we also have another way to provide type information to the TypeScript compiler. We'll talk about that next. We have another way for providing type information, and that is using a declaration or a type definition file. This is useful if you don't want to modify your JavaScript code and add these comments. So let's delete these lines. Now back to our project. Here in the source folder, let's add a new file called tags.d.ts. So the name of the file should be the same as the corresponding JavaScript file, but the extension should be d.ts. D is short for declaration. And this is the same as a header file in C if you have done any C programming. So in this declaration file, we declare all the features of the target module. So our target module is tags.js, and here we have a function called calculateTags. So now we need to declare this in this declaration file. We say declare function calculateTags with income parameter of type number, and this function returns a number. And then we terminate this line using a semicolon. So all we're doing here is declaring this function. The actual implementation is somewhere else in the target module, okay? Now, if we export this, the TypeScript compiler will know that our calculateTags function expects an income parameter of type number. So back to index.ts, if we remove this argument, we get a compilation error saying an argument for income was not provided, okay? So let's bring this back. So using declaration files, we can provide type information to the TypeScript compiler. Just remember, when using this approach, you should describe all the features in the target module. Anything you don't describe will be invisible to the compiler. For example, if we go to this JavaScript file and export another function, say hello, and then we forget to declare this. In this declaration file, this is going to be invisible to the TypeScript compiler. So if you go to index.ts, we're not going to be able to import say hello from the tags module. So when using declaration files, you should describe all the features of the target module. All right, now let's talk about using third-party JavaScript libraries in our TypeScript projects. So I'm going to install Lodash, which is a very popular utility library. You're probably familiar with it, but if not, it doesn't really matter. So let's install this. That was very quick. Now, back in index.ts, let's remove everything and import everything as underscore from Lodash. Now, we immediately get a compilation error saying, could not find a declaration file for module Lodash. The reason we see this is because Lodash is a pure JavaScript library. It doesn't have JS.doc comments. It doesn't have declaration files. So what can we do here? Well, this is where we use a very popular GitHub repository called Definitely Typed. In this repository, we can find declaration files for all the popular JavaScript libraries. So back to the terminal, here we install @types. That is the Definitely Typed repository. Then we type a / followed by the name of the target package, that is Lodash. Now we want to install this as a development dependency because we're not going to deploy this with our application. This is purely for build time, only for compile time, okay? So here we can type --save dev, or I personally like to use shortcuts, so I go with -D. Okay, now back to index.ts, the error is gone. And here we can call underscore dot, let's say clone. So here we have type annotation. So this function has a parameter called value of type unknown, and it returns the same kind of value. So if we pass an array of numbers, you can see value becomes a number array, and here we get a number array in return, okay? So this is Lodash. Now, with TypeScript getting more popular every day, many JavaScript libraries come with declaration files. So we don't need to install their declaration files separately from the Definitely Typed repository. Let me show you another example. So back to the terminal, let's install Chalk. Okay, Now, back to our project. Let's open the Node modules folder. Here's Chalk. Now, in the source folder, here we have index.js, and right next to it, we have index.d.ts. So this is the declaration file for the index module. Welcome back to another section of the Ultimate TypeScript course. In this section, we're going to talk about building React applications with TypeScript. So we're going to build a relatively simple to-do app that shows the essential concepts you need to know when building React applications with TypeScript. This is a good opportunity for you to see TypeScript in the real world. So now let's jump in and get started. All right, let's see how we can create a React project with TypeScript. Now, before we get started, I should say that I'm assuming you know React and just want to learn how to build React applications with TypeScript. So in this section, I'm not going to explain what React is and how it works. If you want to learn React, I have a comprehensive course on my website that teaches you everything you need to know from the basics to more advanced concepts. So here in the terminal, I'm on my desktop. Let's run npx create React app. We're going to call this app reminders app. Now here we add --template followed by TypeScript. So this is going to create a React application configured to use TypeScript. It's going to take a little while, so I'll be back shortly. All right, the installation is done. So now let's change into this folder and open this with VS Code. All right, so here we have a basic React project. As you can see, we have our TypeScript configuration file. We also have this source folder that contains all our source code. Now, one thing that is different is that instead of JSX, we have TSX files. So the same as JSX, but here we have TypeScript and type safety. So now that we have this project, next I'm going to show you how to add Bootstrap to this project so we have a bit of styling so our application doesn't look horrendous. All right, to add Bootstrap, first we're going to run npm install bootstrap. Good. Now we're going to go in the source folder and open index.tsx. Now on the top, just before this line, we're going to import the bootstrap CSS file. So import bootstrap /dist/css/bootstrap.css. Okay. Next, we're going to go to app.css. I don't like any of those styles here, so I'm going to delete everything and add a rule for the body element. Here we're going to add a padding of 20 pixels. Now to test that everything works, let's add a button on our homepage. So let's go to app.tsx. This is our main app component. I'm going to delete everything here. We're just going to keep the parent div element. And here we're going to add a button with two classes, btn and btn-primary. Again, I'm assuming you're familiar with React and Bootstrap, so I'm not going to explain how these things work. Now let's press tab and give this button a label of click me. Good. Now to serve the application, we run npm start. All right. And here's our button. Beautiful. So Bootstrap is working. Next, we're going to create our first component. All right, now let's create a component for showing a list of reminders. So here in the source folder, let's add a new folder called components. And right here, we add a new file called reminderlist.tsx. Now, here in VS Code, I have a very useful extension called React.js code snippets. So go to the extensions panel and search for React.js code. You will find this extension called React.js code snippets. So with this installed, we can type RSF, that is short for React Stateless Function. Now, if we press enter, we get a basic function component. That's very useful. Now here I'm using a function component because that's what most people are using these days. Now here we have a compilation error over props saying parameter props implicitly has an any type. So to solve this problem, we need to use an interface to define the shape of props. So on the top, we create an interface called reminder list props. This is a naming convention a lot of people follow, so it's best to stick to this convention. Now, what do we need to pass to this component? A list of reminders. So we need another interface for defining the shape of our reminders. So we can say each reminder is going to have an ID, which is a number, and a title, which is a string. And then we can say in our props object, we're going to have a list of reminders, or we could call it items, whatever. This is going to be a reminder array. Okay. Now, it's very likely that we're going to use this interface in other parts of our application. So I'm going to take it out of this file and put it somewhere central. So back to our project. Here in the source folder, let's add a new folder called models. Now, some people prefer to call this entities or types or interfaces, whatever you want to call it, it doesn't really matter. So here I'm going to add a new file called reminder.ts. Now, some people prefer to use Pascal naming convention here. So they name this file with a capital R because in this file, we're going to export a default type. That is the reminder interface. I'm not fussed about that. I prefer to use Pascal convention for naming my component files. So a lowercase r works for me. Now, back over here, let's grab this interface and put it right here. And we're going to export it as a default interface. Okay. Now, back to reminder list. Here we have a compilation error. So we press Command and period on Mac or Control and period on Windows and import this interface. Good. So this interface is ready. Now we can annotate props with reminder list props. The error is gone. So now in this component, we're going to return an unordered list, and then we're going to map each item in the list of reminders to a list item. So we can say props.items.map. We can also use object destructuring to simplify our code. So we can destructure the props parameter and pick the items property. That is better. Now we don't have to type props everywhere. So items.map, we're going to get each item and map it to a list item. Okay. Now here's the interesting part. If we hover our mouse over item, we can see that item is a reminder object. This is the benefit of using TypeScript in React projects. So all our objects are properly typed. There is no guesswork. Okay. So we're going to render a bunch of list items. We're going to give each a key, which is going to be item.id. And over here, we're going to render item.title. This is another benefit of using TypeScript. When we type dot, we can see all the properties of our object and their type. So we're going to render item.title. Good. Now let's use this component in our app component. So let's go back to app.tsx. We're going to replace this button with a reminder list. So reminder list. Now here we have a compilation error because we haven't set the props. So we need to set items to an array of reminder objects. So first we need to import the reminder interface. Then we define an array of reminders. And for that, let's just add one object in this array. The ID is going to be 1 and title is going to be reminder1. That's enough. Now we're going to pass that object right here. We're not going to do any state management yet. We just have a basic array that we're going to pass to the items prop. Now, back to the browser. Let's refresh. Here's our reminder list. Good. Next, we're going to talk about state management. All right, now let's talk about state management using the state hook. So over here, we're going to call the state hook to properly store our reminders in the app component. Now in React with TypeScript projects, this function is generic. So here we can type angle brackets and specify the type of object we want to store here. In this case, reminder array. Now let's use array destructuring and grab reminders with set reminders. Now let's hover our mouse over reminders and look at its type. So it can either be reminder array or undefined. The reason we see undefined here is because we haven't initialized this state variable. So you know that in JavaScript, when we call a function, if it don't supply any arguments, by default, undefined will be passed. So that's why the TypeScript compiler thinks this object is either a reminder array or undefined. To solve this problem, all we need to do is pass an empty array here. Now look, reminders can only be a reminder array, okay? Now, when using the state hook, we don't always have to supply a generic type argument. For example, if we call useState and initialize this with, let's say, a boolean, true or false. Now, let's call this variable loading and set loading. Look at the type of loading. It's a boolean. So in this case, we didn't have to explicitly supply this generic type argument, okay? So this is the proper way to manage the state of this component. And with this, we should remove this object from here and put it in this array. Well, technically, we don't need to do this. This is just for demonstration. I want to have at least one object in this array so we can see something on the screen, okay? So let's remove this object. Good. So now that we have state in this component, next we're going to talk about calling the backend to get a list of to-dos or reminders. In this lesson, we're going to use a fake backend service called JSON placeholder. You can find it at jsonplaceholder.typecode.com. On this website, we have various endpoints for getting a bunch of posts, comments, albums, photos, to-dos, and users. So in this lesson, we're going to use the to-dos endpoint for getting a bunch of to-dos or reminders. Now, back to our project. In this component, we are not going to write any code for calling an API because this component should only be responsible for rendering the UI, nothing else. Other concerns like calling an API or storing something in the local storage should be implemented in other classes, okay? So back to our project. In the source folder, we're going to add a new folder called services. And here we're going to add a new file called reminder.ts. Now to call the backend, we're going to use Axios. This is not necessary, but it's a library that I personally use often. So back to the terminal, let's install Axios. Good. Now, on the top, we import Axios from Axios. Now, Axios comes with type definition files, so we don't need to install them separately, okay? Now here we're going to define a class called reminder service. In this class, first we're going to define a property called HTTP. We could call it anything, but HTTP makes sense. We're going to set it to axios.create. Now here we pass a configuration object. Look, because we have TypeScript support in Axios, we can see the type of this parameter, which is Axios request config. So if we press Control and space here, we can see all the properties and their type. So here I'm going to set base URL to, now back to the browser. Let's grab this URL and paste it right here. So that is our base URL. And now we're going to define a bunch of operations or methods for getting to-dos, adding them, and removing them. So let's define a method called getReminders. Here we call this.http.get. Now this get method is generic, so here we can type angle brackets and specify the type of objects we expect to get. We're going to get a reminder array, okay? Now here we specify the URL or the endpoint, which is /todos. Now this returns a promise, so we need to await it to get the response. And we need to make this method async. And finally, we return response.data. Nothing fancy, you're probably familiar with this approach. Now, we need another method for adding a to-do. So add reminder, takes a title of type string. Here we call this.http.post. We're going to post a reminder object. Now for the URL, again, we're going to pass /todos. And for the data, we're going to pass an object with the title property. Once again, we await the call to get the response. And finally, we return response.data. And we make this async. And one last method. That is remove reminder, which takes an ID of type number. And here we call this.http.delete. We don't need to supply a generic argument here. We just pass a URL like /todos plus ID. As simple as that. Now let's await the call to get the response, and here we return response.data and make this async. Okay, so our service is ready. The final step is to export it. So export default. Now, instead of exporting the reminder service class, we're going to export an instance of this class. With this, the consumers of this module don't have to new up an instance of this service every time. Okay, that's just a little bit easier. So we're done with this step. Next, I'm going to show you how to use the effect hook to get the list of reminders when our application starts. So we created our service. Now here in app module, let's import it. Import reminder service from, we go to the services folder and grab reminder. Now in the app component, first I'm going to remove this hard-coded reminder. We don't need it anymore because we're going to fetch all of the reminders from the server. Okay. Now over here, we're going to use the effect hook. So use effect, we give it a callback. And to make sure that this gets executed only once, we pass an empty array here. Again, at this point, you should be familiar with all these little details. If not, go back and watch my React course. So in this callback, we're going to call reminder service.get reminders. Now this returns a promise, so we need to await it and make this async. Now the problem is that this callback that we pass to the effect hook cannot be an async function. So we need to extract this and put it somewhere else. So let's define a function expression. We're going to call that load reminders like this. So we await the call and get our reminders. And then we call set reminders and give it the reminders that we get from the server. Now we pass a regular callback here. And over here we call load reminders without awaiting it. Okay? So let's see what we get. Back to the browser, refresh. Here are all of our reminders, beautiful. Now the last thing I want to do in this lesson is applying a couple of bootstrap classes to make this look a little bit nicer. So let's go to the reminder list component. Okay, here is our UL. I'm going to give this a class called list group. And for our LIs, we're going to apply a class called list group item. Let's try again. Beautiful. All right, now let's add a button for deleting reminders. So here in the reminder list component, I want to add a button next to each reminder. So here's our list item. I'm going to break this down so we can see clearly. So right after the title, I want to add a button with a couple of classes, btn and btn danger, to make it look red. And let's call this delete. So here's what we get. It's not too bad, but it's a little bit too red. So let's use an outline button. So I'm going to change the second class to btn outline danger. Look, that is better. Now the button is currently too close to the text. So let's add some horizontal margin. For that, we're going to use a bootstrap class called m for margin, x for horizontal, and 2, which is the amount of margin we're going to apply. Now, that is better. Now, the last thing I want to do here is making the corners round. And for that, we're going to use another class called rounded pill. That is much better. Now let's implement deleting reminders. So you know that reminder list is only responsible for rendering the list of reminders. So we're not going to delete reminders in this component because the state lives in the app component, right? So this is where we're going to change the state. So here we're going to define a function for deleting reminders, and then we're going to pass that function as a callback to the reminder list component. So let's define a function called remove reminder. This function should take the ID, which is a number. And for now, let's just log the ID on the console. Okay. Now we want to pass this function as a callback to the reminder list. So first, we need to change the props interface. Here we're going to add a new property called onRemoveReminder, which is a function that takes a number and returns void. Okay. Now back to the app component. We're going to set onRemoveReminder to remove reminder. Okay. Now the final part is to go in the reminder list component and handle the click event of this button. So we set click to, here we pass an arrow function, and here we need to call onRemoveReminder. So let's grab it here, onRemoveReminder, and then we call onRemoveReminder and give it item.id. So item is our loop variable, okay? Now, I made a mistake here. This should be onClick. Okay, good. So let's test our implementation up to this point. Back in the browser, delete, delete, delete. Now let's look at the console. So here are the IDs of the reminders I tried to delete. So all the plumbing is working. Now the final part is to actually delete these reminders. So back in the app component, in this function, we're going to go to our reminders array and use the filter method to get all reminders except the one with this ID. So reminder.id does not equal ID. And then we can pass the result to set reminders. As simple as that. Now let's test it. So delete, delete, delete. Beautiful. So deleting is working. Next, we're going to implement the ability to add reminders. All right, now let's create a form for adding a new reminder to this list. So let's add a new component called new reminder. Once again, we type RSF to generate a function component. Good. Now we have a compilation error on props. I'm going to temporarily remove props. We'll come back to it shortly. Now, one thing I forgot to tell you earlier is that here we can annotate the return value of our function components with jsx.element. And with this, if we don't return something, or if we return a different kind of object, we get a compilation error. So by annotating the return value of our function components with jsx.element, the TypeScript compiler will ensure that we return a JSX element from our function components. Okay? It's not necessary, but it's a good practice to follow. So let's bring this back. Okay? Now, instead of a div, we're going to return a form. Now, inside this form, we're going to add a label. Next to that, we're going to add an input with the class of form-control. And next to that, we're going to add a button with two classes, btn and btn-primary. Now, we can also give it round corners by applying rounded peel. That's better. Now, if we press tab, we get the markup. Beautiful. Let me reformat it so you can see clearly. Okay. Now, I'm going to give this input the ID of title and use the same value for the HTML4 attribute of the label. With this, when the user clicks on the label, the input will get focus. Okay. Now we should make this a submit button. So we set type to submit. Okay. We should also give it a label like add reminder. I think that's good for now. So let's add this to our app component. We go to app.tsx. And right above the list, we add the new reminder component. Good. Let's see what we get. Okay. The button is too close to the text box on the list. So let's give it a vertical margin. So back to the new reminder component. Here's our button. Let's apply a vertical margin. So M for margin, Y for vertical, and let's say 3 for the amount. Okay. That's better. That's reasonable. So I'm happy with how the form looks. Now we need to manage the state of this input box. So back to this component, we're going to use the state hook, use state. We're going to initialize this to an empty string, and then we use destructuring to grab title and set title. Now we need to do two things here. First, we need to set the value property to title. And second, we need to handle the onChange event. So over here, we get an event, and here we call setTitle to e.target.value. Now note that here we have IntelliSense. So if we type e dot, we can see all the properties and methods of this event object. If you hover our mouse over e, we can see e is an instance of React, the change event, which is a generic type. Okay. So here we're going to access e.target.value. Okay, our form is ready. Next, we're going to handle form submission. All right, now to handle the form submission, here we set onSubmit to a function. So let's define a function called submitForm that takes an event of type React.formEvent. So in the previous lesson, we talked about the change event interface. Here we have the form event interface. Now we say e.preventDefault to prevent the default submission of the form, so we can do everything on the client. And once again, here we have IntelliSense. So if you type e dot, we can see all the properties and methods of this event object. Beautiful. So e.preventDefault. Now, before going further, let's just log the title on the console to make sure all this plumbing works, all the basic integration works. So let's log the title. And then we pass submit form over here. Let's test our implementation. So back in the browser, let's bring up the console, type something, click. Okay, we have the title, beautiful. Now let's implement adding a reminder. Now, we're not going to implement that logic in this component because that's the responsibility of the app component, because this is where the state lives, right? So similar to removing reminders, we're going to define a function for adding a reminder and then pass that as a callback to our child component. So let's define a function called addReminder that takes a title of type string. Now, once again, before getting distracted with too much complexity around adding a reminder, I just want to log the title on the console to make sure that the integration between these components works. So we log the title. Then we need to pass this function as a prop to the new reminder component. So on addReminder, we set it to addReminder. Now we have a compilation error because this is not a valid prop for the new reminder component. So back to this component, let's define an interface called new reminder props. Here we need a property called onAddReminder, which is a function that takes title as a string and returns void. Now let's add props to this function and annotate it with new reminder props. Now again, we can use object destructuring to grab onAddReminder. And then instead of logging the title on the console here, we simply call our callback. So onAddReminder, and we give it the title. Let's make sure our implementation works up to this point. So back to the browser, I'm going to change this to B, addReminder. You still see the result on the console. Beautiful. Now we're ready to call the server and add this reminder. So back to the app component, instead of logging the title on the console, we're going to call reminder service that add reminder. And here we pass the title. Next, we need to await the call and get the new reminder, which has an ID generated by the server. Now, because we have used await here, we need to make this async. And finally, we call set reminders, give it a new array with the new reminder and all the existing reminders. So back to the browser, let's add a new reminder here. Okay, it works, beautiful. And we can also delete it, perfect. Now, the final thing I want to implement here is clearing this input field upon adding a reminder. So back to the new reminder component, after we call onAddReminder, here we set title to an empty string. Let's test it. So one more time. Okay, the input is cleared, beautiful. Now, what if we submit the form without providing a title for this reminder? That's not good. So we want to create a reminder only if the title has a value. So back to our form handler, right here, we're going to do some basic validation. We can say if title is not truthy, then we're going to return. Now back to the browser, let's test this. So nothing happens, beautiful. So we're done with this application. Of course, we could take it to the next level. We could implement a loading indicator. We could handle HTTP errors. So if you cannot connect to the server, then we want to show some error to the user, right? But all of that is really outside the scope of this course because here our focus is on React and TypeScript integration. We are not building a full-blown React application. So I leave it up to you as an additional exercise. We have reached the end of this course. Thank you so much for taking this course, and I hope you have learned a lot, and I'm going to see you again in my other courses. If you enjoy this course, please support me by telling others about my coding school. I really appreciate your support. Once again, thank you, and I wish you all the best.